Very good morning. Welcome to day 5 of 5 days FTP come workshop on contemporary image processing and cybersecurity application. We are in day 5, last day, right? So the day 5, the first session is going to handle by Dr. Kanchan Lata Keshav ma'am. She is going to deliver talk on um, malware detection and classification. It's my honor to introduce ma'am. Yeah, Dr. Kanchanlata Keshav ma'am, she is currently working as an assistant professor in the Department of CSE Cybersecurity IIIT Kottayam. She has done PhD from IIIT BM Jabalpur. She has 16 years of teaching experience. Her research interest is in image processing, mesh-free approach, machine learning, natural language processing. She has published 36 papers in various SEA journals, international conference, and book chapters. She has guided two PhD scholars successfully. She is also a reviewer of various SEA journals. Let us join with me to welcome Dr. Kanchanlata Keshav ma'am. Welcome you, ma'am. So over to you.
Thank you so much, sir, for nice introduction. And good morning to all of you. And thanks for inviting me, sir, for this talk. So let's start. Should I share my screen, sir?
Yes, please share. Ma'am.
Okay. Sir, so my screen is visible?
Yes.
Okay.
But your slide is not showing, ma'am.
That's what I'm also thinking.
Okay. Can you please share it as the entire screen? Yeah, now it's okay.
Yeah, no, it's
Yeah,
okay.
fine.
Just
You can move to our presentation mode and
yes, sir. So just so good morning to all. So today's my talk is malware detection and classification. So first, today's talk of agenda is that first we'll discuss about the introduction of malware, then we'll discuss about that various types of malware, and then various malware analysis techniques. In that malware analysis techniques, we'll discuss about that static analysis and dynamic analysis. Then we'll discuss about that malware detection techniques and then various features of malwares and how we can apply those features for malware detection using machine learning techniques. And at the same time, we'll also discuss that image-based malware detection and classification using deep learning techniques. So first, we'll discuss about the basics of malware. It's a very basics. I have started from the basics so that we can just revise or refresh all the things. So first thing is what is malware, and we'll go for the some hands-on session also. So what is malware? So basically, the malware is a kind of unwanted software that is installed without the consent of computer or any other digital devices. So it is a software. Basically, it is designed to cause damage or gain access to the computer, server, client, or computer networks. So basically, it is designed by that hackers or hackers or that they are that software developers, but they are hackers. So their intention is malicious. So basically, they want to damage or gain access to our computer, server, or client, or any computer network. So basically, the malware it is described with that two words, that is a malicious plus software. So mal is from the malicious and ware is from software. So it is described from this malicious software. So actually, it is the biggest threat because every day approximately 3 million new malwares are created by the hackers. And it is why it is the biggest threat for the organization or for the individual, because the malwares may sometimes go undetected in a several weeks in a network. So that's why it is the biggest threats for the organization or individuals. So various examples of malware are there. That is a viruses. We'll discuss in detail about all the things. So viruses, that is a creeper system, that is a virus. It comes into the picture in 1971. Worms, that is a Morris worms, it came in 1988. Trojan horses, that is animal is a Trojan horses, it came in 1975. And the spyware, around is an example of a spyware, and then various adwares are there, and then PC cyber, it's a ransomware. So we'll discuss in detail about all these types of malwares. So first thing is I want to discuss that what is the intention of malwares, although we know that some of the intentions of the malware, but actually the intention of the malware is it can delete the sensitive data and file, and it can encrypt the data by calling the file modification calls, and it can encrypt the files and ask for the ransomware to get the decryption key. So one of the example of this is a Stuxnet, that is a ransomware. One of the example is that is a WannaCry. WannaCry, it's a ransomware. So basically, it targets the computers which are running the Microsoft Windows operating system by encrypting and locking the data and demands for the ransom amount in Bitcoin. It came into the picture in 2017. And it can that malware can steal the confidential information. It can install other applications also, and it can multiply and spread the malicious softwares in all the computers that is in our network. And it can monitor the user activities. What are the whom are the active users, and what are the active processes and all. It can alter and hijack the core computing functionality by using the system calls. It can hijack the process by memory injections, and it can stop the services and slow down the system, and it can give access of your system to the attacker. If your system is compromised with the malware, so it can give access to your system to the attacker, and it can gather and send that confidential and sensitive information. It can provide those sensitive information to the attacker, and it may take part in a larger attack. How? There is a specific type of malware families there that is known as that botnet, in which the malware are built and it can take part in the larger attacks. So in this case, when the machines are infected with such botnets, they can turn into a zombie computers and act as that master's computer. So all the commands and controls will be under in that master computers. So basically that we know how the malwares are distributed. So some malwares are designed to attack to a specific target, and some malwares are designed to attack on any possible machines. So basically it comes with that direct access to the target computers, or with the help of external storage devices. It comes as an email, as an attachment, or in the phishing attacks. So basically the attacker puts a link into the email, or while downloading any websites. So some hackers, they can compromise a popular website and attach its malware. So basically that attackers normally use the celebrity names as a malware for the malware distribution. So when we'll download something from the website, our system get infected, and it comes with the malware advertising also. So some games are there, like spin games, or some concession will be there. So that time that our system gets affected with that malware. So now next we'll see that what are the various types of malwares are there. So basically that malware, as we have seen that malwares have the different purposes, and there are different intentions. So depending upon the purposes and their intentions, that malware can be divided into various categories. So basically that three things, based on the three things it is categorized, that how they infect the computers, and how they spread, and what their intentions are. So first is a very basic one, that is a virus. So basically virus, it attach themselves into a clean file and infect other clean files and the devices. So the intention of this virus is to damage a system's code functionality, deleting or corrupting the files. So normally the virus appears as an executable files. Now, second type of malware is a worms. Worms basically it infect the entire networks of device, either local or across the networks by using the network interfaces, and it uses each consecutively infected machines to infect others. Another one is the Trojan. So I think you might be familiar with all these malwares, but just I am just revising the things. So Trojan is basically a it appears as a legitimate or useful software, but that intention of these Trojans are malicious. So basically that Trojans, they create the backdoors in our security, and it will allow the malware to enter in our system. Another one is that ransomware. So ransomware, as I told you that ransomware basically it locked down our computers and our files and demands for the payment to unlock it. So one of the example of this ransomware I have given you, that WannaCry. It comes into the picture in 2017, and it asks for that it has targeted that all the systems, Windows, Microsoft system operating system, and and it was asking for that payment in that Bitcoin. So another one is that backdoor. So backdoor, it allows for that it allows for the unauthorized access to the functionality. So basically that backdoor, it negates a normal authentication procedure to access the systems, and when we'll negate the authentication system, so remote access is granted to the resources within an application, so that attackers can access the database and file servers, and it gives the attackers to the privilege to access the resources in our system. So another one is that botnets. So in that backdoors, actually it gives that attackers the ability to remotely issue the system commands and update the malware. So another kind of malware is a bot or bots sometimes. So botnets are networks of infected computers, so that are work together under the control of an attacker, like the zombie computers. That one example I have given. So another one is that keyloggers. So keylogger is a malware that records the keystrokes on a computer, whatever that we typed. So it records those keystrokes on a computer, and that keystrokes are sent to the attacker, like our password or our credential, our login details, our credit card information. And another one is that the rootkit. So this is a kind of malware that infects our device drivers. So these rootkit are actually difficult to detect because they start even before our antivirus started. So this rootkit is because that its gains are concealed within that. Basically, it gains a root level access, and it conceals the existence of other malware. So it is very difficult to detect these rootkits. Another one is a logic bomb. So logic bomb is basically it's a set of instructions. It is secretly incorporated into a program. So if any particular condition is satisfied, then it will be carried out. So with the harmful effect. So basically that like if then else condition, we put that if this condition will be true, then something will happen, and that will be a very harmful. So another one is that adware and spyware. Many times we have seen this adware while accessing that any website. So basically adwares are not a malicious in nature, but it can give access, it give the permissions, or it may provide the entry gate or gateway to that other malwares. So and moreover it consume the system resources also. So that's why that malware is dangerous. Now, related to this malware, it's a spyware. So it is again a malware that is designed to spy on you or whatever the work we are doing in our system. So actually that it hides the background and take notes on what we do in online. So many times we have seen that when we visit any website, so normally that it comes that it is recommended that when we access the another website. So basically, that spy it can take your passwords, or again it can take that credit card information, and it can just watch that our surfing hobbies and other things also. So that spyware and adware both are related. So apart from this various types of malwares, we can divide these malwares as two types. That is a mass malware or targeted malware. So basically, that the mass malware, the intention of this mass malware is to infect as many as machines as possible. Is I have given you one example is a WannaCry, and it is mass malware is the most common type malware, and it uses the well-known vulnerabilities. So attacker is not that much skilled that average attackers can also use can develop the mass malware. Another type of malware is a targeted malware. So basically, the target malware they target to a specific organization, and actually they want to do that a large scale of harm. So basically, it uses a zero day vulnerability. So so that zero-day vulnerabilities, it will not be easily detectable by that malware detection systems. So it is very difficult to detect and prevent and to remove this targeted malware, and it requires advanced analysis also. As an example of that targeted malware is the Stuxnet. It comes into the picture in 2017, sorry, in 2010. So intentionally, initially the intention of this malware is to it is to target Iran's nuclear facilities. It is basically a worm, and in the time over the time period, it got mutated and spread into the other industrial and energy producing facilities also. So this the targeted malware target to a specific organization, and that their intention is to harm that large scale. So normally we see that that malware may be any executable file, but it's not like that. Malware may be different kinds of types of the malware, or in varieties of malware we'll see in a different form. So basically, that malware is it may be executable malware, or it may attach as documents like our PDF or Word or Excel, or it may be a web script. So in a website may be compromised by that attacker, or in the web backend script may be possible, and malware may be attached as the images or videos or music also. So basically, in that malware, basically that executable. So there are various extensions may be possible. Normally, in that .exe we use for the Windows executable, and .sh for that Linux-based operating system, .f for the Mac operating systems. And actually, all these are interrelated. So in the Word or Excel, there may be a macro, and in that macro may be a executable. So so that macro may be hidden with that Word or Excel file. So there may be various vectors of the malwares may be possible. Now, next one is sorry. So there are various types of malwares are possible. Now, next one is that that portable executable file format. So basically, it's a most common file format for the executables on Windows platform. As I told you that there are various types of malwares are possible. So why we are discussing this portable executable file format? Just actually, it's a most common file format for executables on Windows platform, and most of the malwares are written for the Windows platform, and all the .exe and .dlls are also a PE files. So it contains the information that the operating system needs to run the executables. And when we'll thoroughly study this portable executable file formats, it gives us a hint about the functionality of the malware, how it interact with the operating system and time spent and other details also. We'll see the details. So basically that PE file headers, that is a portable executable file headers. Mainly it is divided into two parts. One is the header and second one is that section. So in the header again, it contains that various additional information, that is MS-DOS header or PE header, optional header, section tables, import or export address table. And in that sections, it contains the code sections. Code section basically it contains that machine instructions, so we can analyze those machine instructions. Data sections, it contains the various variables and constants. And other one is that resource section, which holds that various fonts and images also. So we'll see in a very I mean that in a descriptive format. If you want to you want to just detailed description you want to see, then that link is already given here. Just that short description I'll give here. So here basically that portable executable format. So first thing is that MG header, or this is a DOS header, basically defines a file as an executable binary. So basically, it contains that it contains a magic number. This is a file signature. It contains a magic number. So magic number is in that 5A 4D or in hexadecimal. It is in a 5A 4D and MZ in a ASCII. So it is also known as file signature or magic number. And now in the DOS system, it exists for the backward compatibility. We'll see that whether it is compatible with the DOS, but nowadays in the recent version of Windows, there's no function of DOS. So it print a message that the program cannot be run in a DOS mode. And that P header, it defines that executable as in PE. It holds the signature to represent the PE file. It also holds that machine type number. It's a 32-bit machine or 64-bit machines. It contains the number of sections or time and date stamps and size of the optional header. So number of sections to check for the functionality of that malware, and time and date stamps. These features are very important. So now that optional header, it also contains that size of the code, size of that address of the entry point of the code, preferred base address, and that size of the images, and that operating system versions. So just brief description I am giving. Now another one is the section tables. It contains that virtual size of that sections, size of the raw data, and characteristics of that sections. So in the second part, that is the sections, it contains that .txt extension. So it contains the executable code for the application. .bss, it holds the uninitialized data for the application. Raw data, it represents the read-only data on the file system, such as strings and constant. The data, it holds the initialized data for the application. So various fields are there in the sections, and when we analyzed this malware, we can collect all this information and we can use those information for that malware analysis. So we can extract the various features from the PE files. Okay. So another one is that malware analysis. So basically that obviously if there is a malware, so we have to analyze. Suppose a malware it has entered in our systems or in our computer network, so we need to analyze that malware. So basically what we do in the malware analysis, it involves that we dissect the malware to understand its functionality, and to just understand that how it works, where is the origin of the malware, what is the potential impact of the malware. Okay, so the goal of malware analysis is to understand the three things. That is the intention of the malware. So we'll check whether a malware is collecting any information from our system or network, or it is communicating with anyone else in the internet, or it is encrypting the files, or it is attempting to stop any services, or it is creating or deleting any files. So, or it is looking for the database server or email server. So basically that when we'll analyze the malware, we can understand that whether it's a mass malware or it's a targeted malware. So while analyzing the malware, we can improve our defense system, and we can just protect our applications and servers. So there are two kinds of malware analysis is there. That is a static malware analysis and dynamic malware analysis. So we'll just see that in brief what is that static malware and what is that dynamic analysis. So basically that static malware or static analysis, not malware. So static analysis, it is also known as a code analysis. So basically we don't run the malware, we just analyze the malware in instructions basis. So we just analyze each instructions line by line, and we'll analyze and we'll collect that useful information from that suspicious binary file, and we can just detect whether this is a malware or it's a legitimate software. So basically that static malware, it provides static analysis, it provides information about the functionality of the file, and it produces a set of signature features. So as I told you that we don't run or we don't execute the file, that executable file, we just see that we just analyze that each instructions line by line, and we try to produce a set of features. So these extracted features are used to predict whether the file is malware, malicious software or not. So basically in the static analysis, we analyze the portable executable header and sections. Is That's why I have introduced you that portable executable file. So that portable executable file or P header, basically it provides about the linked libraries, important and exported functions by that attacker, or it will contains that various metadata about that executables. So and we can just we can analyze the strings of characters that can contain the reference to the modified files, or that access file path by the executables. So in the strings of characters, mainly we can just find the URL, domain names, IP addresses, and names of the loaded DLLs, dynamic link libraries, and that various registry keys. So we will see in detail that various other features also. And and it search for the packed or encrypted code that is used by the malware developers. Basically that malware developers, they used to packed, or they used to mask that or they used to hide executables by using some compression or by using the encryption. They encrypt that malware executable, so it will be very difficult to analyze if our malware is encrypted one. So we can search for whether the malware is a packed or it is encrypted code, what kind of encryption they have applied by the developer. So another thing is in the static analysis, we disassemble the program. So in disassembling the program, we translate the machine code into assembly language code. So that is a reverse. So first we load the executable into a disassembler, and that disassembler translate that machine code into assembly language. And that assembly language will be written, we can find out various opcode, and that will be understandable, and we can understand that what kind of operations that malware is going to perform. So these two things we are going to do in that static analysis, and the static analysis basically will extract that various features by the static analysis. That is that structural properties of the features. So in that in the structural properties of the features, we extract the entropy. So basically entropy is a measurement of randomness. So if there will be a more randomness, there will be a entropy value will be high, and we can understand that file is a encrypted one. And we'll check whether that executable is a compressed or not. So with the help of this entropy features, we can find that whether the executable is encrypted or not. Similarly, we'll go with the code analysis, that we can understand that various functions calls Their code blocks or code patches, basically similar family of the malware, they use the same kind of functions, or they use the same kind of code blocks or same kind of code patches. So by extracting those functions calls, or by analyzing those functions calls and code blocks and code patches, we can analyze that whether it's a malware or not. Similarly, we'll find the file header and then extensions of those executable. And the same time, so we can extract the various strings, various that phrases and words like file name and file path for creating or accessing that malware files or attackers they have used. And similarly, we can check for the various libraries and functions used in the program, that URL, IP addresses, and registry keys. So basically, that registry keys entry in Windows, it's a powerful tool, because registry can disable, and it can disable the keyboard and that mouse also by changing its values. So malware is trying to infect our PC by changing that registry entry. So that's why it's a powerful feature. And the registry entry can disable as I told you, that keyboard and mouse by changing its variable. So it's a very important features when we analyze this during that static analysis. And similarly, when we disassemble our executable, then we can extract the various functions calls, API calls, and system calls. So basically, that we'll check for that in the system calls. We'll check for that specific system calls that malware is trying, and to just inside that system to check whether which kind of system calls they are just trying to execute, or which kind of that API calls they're trying to execute. So another one is that that's just I mentioned that various kinds of tools though, which are available for the static analysis. That is a virus total, that is a web-based tools that is managed by the Google. So hashcalc, it gives the hash value of the executable. HXT, it is used to identify the file types. It basically calculate the magic numbers, that is a file signature. XCNFP to check whether the file is executable or not, or we can identify with these tools we can identify that file is packed or not. And bin text, it is used to extract that strings, as I told you, the string features. And P studio, it is used to analyze the PE file. So all these are available, we can use for the static analysis. So another type of analysis are dynamic analysis. So dynamic analysis, it is also known as the behavioral analysis. So basically, here we execute the program and we monitor its behavior. So in the static analysis, we don't run that program, but here in the dynamic analysis, we run the program, and and while executing the program, we'll monitor the behavior of that malware. So basically, that static analysis, we just try to find the signatures. So for that, if the signature is not available, for example, in the 0-day attack or 0-day vulnerabilities, so we can go with the dynamic analysis. So dynamic analysis, how we can perform this dynamic analysis? So we just run our executables in a safe environment, that is a dedicated physical or virtual machines, so that we don't want to expose the user system to unnecessary risk. To avoid those unnecessary things, we just set up a physical machine that are isolated with the networks or disconnected from the internet or any other network, to prevent the malware from spreading. And same way, we can use that virtual machines, or that related to this virtual machine, there is a sandbox. So this is again that physical or virtual environment. It gives us that physical or virtual environment for running the malware, and it isolates the executable from our system resources and applications. So another that automated malware analysis toolbox or a sandbox already exists. That is a McAfee, that is Advanced Threat Defense. Wildfire, Cuckoo, it is an open source sandbox. Any.run, that is a cloud-based sandbox. Other examples are also there. You can explore all the things. Only examples I have taken. Another one is that for that, these are that sandbox. that we can use for the automatic analysis. Another one is that dynamic malware analysis tools are also available. That is a Process Explorer, Autorun, Process Monitor, or Rakshot. So these are the examples of tools that we can use for the dynamic analysis. So what are the various features we extract during that dynamic analysis? So basically that we'll trace that API call. So what kind of that API calls that that binary executable is trying to call, or we'll check for the file integrity check. So in the file integrity check, basically that malware is changing the certain files in a closed malware environment. So we'll check for that. We can check for the file integrity in the closed environment or in the critical system location. So in the critical system location, we'll check for the kernel files or system 32. In Linux, we'll check for that kernel files, and the system 32 in Windows. And Linux, we can check for the root directory if anything is changing or not. So another thing is we'll check for the environment variables. So in the environment variables, it also plays an important role in controlling the other applications. So basically the programs depends on that various environment variable, and we choose that the workflow of the programs. So the malware can change the environment variables. So we can check for the global variables or domain level variables or user level variables. So that malware can change the environment variables, and applications needs to follow those. So we can check for all these kinds of variables. Similarly, we can check for the registry entries. As I told you that registry malware can disable the keyboard or mouse by changing the registry values. So we can check for those registry entries, and we can check for the system calls, whether that malware is using the specific system calls, or malware is malware is trying to make any changes to that virtual machine or that system. So next one is that memory fingerprinting and memory injection. It's a very important feature. So basically in the memory fingerprinting, we take the snapshot of the memory before executing the malware, and after executing the malware, again we take that snapshot. So after the and then we can compare that snapshot if anything changes in that. So we will check that malware is trying to make any changes or save store, or malware is trying to just make any changes to that executable. So actually, in the memory injection, that actual malware is injected in that memory. So that thing will check during that dynamic analysis. So what are the advantages and disadvantages, or what are the characteristics of malware analysis? That is a static analysis. Basically, it's a fast and safe. It does not require much resources, and it is good in analyzing the multipath malware. But if malware is obfuscated or it is polymorphic, it changes its behavior, then it is very difficult to analyze with the help of that static analysis. And we cannot detect the unknown malwares also, because that static malware is based on the signatures of that malware, but it gives a high accuracy. And same time that dynamic malware, it is very time consuming and vulnerable, and it requires additional resources also, and it is very difficult to analyze a multipath malware. And we can analyze a polymorphic and obfuscated malware also with the help of dynamic analysis, because we'll see the behavior of this malware, and that's why it can detect the new malware, but accuracy of this dynamic malware is low. So based on this static analysis or dynamic analysis, there are two types of detection techniques are there. That is a signature-based detection techniques. So in the signature, that is we just extract the various patterns of that malware, of that executable files. Okay, so these patterns we can use for the detection of those malwares. Basically, that our antivirus softwares or that our IDS, intrusion detection systems, or IPS and firewall system, that is a part of our security system. This is based on the signature based detection systems. So as I told you that it cannot detect that 0-day or new malware, because these malware signatures are not supposed to listed in the signature database. So first we create the database of the signature, but the 0-day or a new malware attack, the signature will not be available in the database. That's why it will not be it will be difficult to detect that. And as I told you, that it uses a less resources compared to the dynamic one or other techniques. Same that behavior based detection, that is, it is based on that dynamic analysis. So we observe the behavior of the program executable files to conclude whether it's a malicious or not. So the programs with the same behavior are collected based on the dynamic analysis, and it can deal with the known malware. It can also generate that, but at the same time, it also generates a greater amount of false positive than that signature based method. So and it reads that additional resources like sandbox and VM and all to analyze that malware. So it's a time consuming. Another one is that heuristic based approach. It uses the data mining and machine learning techniques to learn the behavior of an executable. So we have to extract the various features, that we have already discussed, that API or system calls, upcode by disassembling that program, and grams control flow graph. So it provides us that automation of that automatic malware detection, and it is a less expensive also, and we can improve that our performance in time. So in very less time we can detect that malware. So there are automated malware detection systems are there. So there are two terms are there: malware detection and classification. So malware automated malware detection basically will predict whether the executable file is a malware or it's a benign. So basically the output will be in a 1 or 0. If it will be a malware, then 1, or it will be a benign, then it will be a 0. And the same time in malware classification, we can predict that various type of malware of an executable. So because a number of different malware families are available, so we can just classify those different kinds of malwares, like whether it's a virus or adwares or trojan or logic bombs. So based on that capabilities, or based on the various features of that malware. So basically that in the now moving towards this ML based detection and classification. And so as we know that in that ML based classification or detection, we requires a set of extracted features from the executable, and we'll use those extracted features for the training of the ML model. And this trained model is used for the detection and classification of new files. So first we'll train the model with that existing one, and then we can classify with that new files. So based on the input, whatever the input will provide for the malware classification, it is categorized as a two kinds of classifier. That is a raw binary classifier, and otherwise a feature-based classifier. So basically, in the raw binary file, we can give that raw byte content from the executable as an input feature. So in that raw binary files, that size will be used. And the feature-based classifier, basically, as I told you, that we can extract the various static and dynamic features while that is static and dynamic malware analysis. So we can use those feature-based features to build a feature-based classifier. So again, that based on the features this I have taken from the existing author. So this is a survey paper. If you want to just know more about this, you can just refer this paper. So based on the feature taxonomy, there are static features and dynamic features. So in the static features, we expect the strings, byte engrams, upcode, and then API function calls. And that static features may be entropy based, image based, and then function call graphs, control flow graphs. And the dynamic features will check for the memory and registers uses, and the various instructions traces, network traffic, and API call traces. So various authors, they have used that various features. So basically that in the Windows system, we can just extract the static features from the PE file headers. That's why I kept that PE file headers, because it's a very important to analyze that various features. So, or we can just take that from the assembly language source file after disassembling. So, in in Android system, the static features are extracted from the disassemble APK. So various disassembler tools for Windows and Androids are also available that we have discussed. So we can the string features are nothing but it's a sequence of characters related to URLs, IP address, and access file path, registry keys, name of the modified file by the executable. This we have already seen. And the byte engrams. So sequence of n bytes in a p headers or the assembly language code will take as an input. So engram, it is a sequence of n adjacent items in a sequential data. So the large number of sequences in a n bytes. So n we can take it as a n 1 to 8 as an input features, and we can give to the ML model for training. So here that again, that large number of engrams may be possible. So we have to go for the dimensionality reduction in case of machine learning, because if the dimension will be high, that there will be a chance of the overfitting. So another one is that upcode. In the opcode or mnemonic engrams, will check for the consecutive opcode or operational code instructions for the assembly language source code. So we'll check for that instruction sequence, that is a when we'll deassemble it into that assembly language, we can just find the various operational code, that is a call, add, move. So suppose we'll take the 3 gram of code, so we can just take it as a call, add, and move from these 3 instructions. So these malware samples, as I told you that the malware samples with the same family, they will use the same operations or same code. So this we can use for the malware detection. Similarly, for the API functions calls, so it is a request to the operating system for accessing the system resources, that is a networking, security, and file management. So this API functions calls have the various different features, and it can reveal that behavior of the malware. So we can use this API functions calls. Various authors, they have used this for the malware detection, because API functions calls will be different in case of malware and in case of that benign file. So these features also we can use. And similarly, for the entropy based features, is earlier also, as I told you, that it tells a randomness or that statistical variations of the bytes in a file. So we can just detect whether file is compressed or encrypted. So so if the file is encrypted, obviously the entropy will be more, and more. So that entropy features will be a very important features for detection of that malware. So, and for that, there are various families of malwares are there. So that with the same family of malware, the entropy will be similar. So this entropy we can use, and the various authors, they have already used this structural, this structural properties of the malware for the malware classification. And next one is that image based features. So we can just convert that binary content of the malware as a grayscale images. So so that various because that various family of the malware, their binary content will be different, and that grayscale image will be different. So we will discuss in detail that various families of the malware images. So here are the textural features we can extract from this, because textures are different for the different family, and it will be same for that same family. So this that binary content we can convert into as a grayscale image, and we can use a grayscale image for the malware classification. So similarly, for the function call graph, that we can use it as a feature. So it is a directed graph whose vertices represent the functions of a program, and the edges, it will tell us the functions call. So the sequence of function calls, we can check with the function call graph, and we can use it as a features. Same way that control flow graph, this one author, he has used this control flow graph. So what is this sequence of that calling of those functions that so this basic block is a linear sequence of program instructions. So it will have the entry point, that is the first instruction executed, and then exit points will be there, that is the last instruction executed. So this we can just traverse a path of that control flow and during the program execution. So this also we can use as a feature for that malware classification. So in the case of dynamic features, we can see that various memory and registers uses. So values is stored in the memory and different registers during the execution. We can just check whether it's a benign or malicious. So we can monitor the memory content in registers values before and after that invoked API call, and we can just find out similarity scores between the benign and malicious files, and that similarity scores we can use to train that ML model. Similarly, we can find that instruction traces, and this is a sequence of the processor instructions that is called during the execution of the program. So this dynamic instruction traces, we can as we have already seen that it's an indicator of the program behavior. So these instructions are also we can use to detect that malware, whether it's a malware or not. We can give as a feature in the machine learning model. So various authors have used this kind of instructions. So you can just take an overview and you can get an idea that how they have applied and what you can do in future work. So say similarly that network traffic, we can monitor the network traffic while entering and exiting the network. It can also provide the helpful information to detect the malware behavior. So if the malware is infected with the host machine, it will try to establish a communication with the external server to download the updates or other malware, or it can just provide the private and sensitive information from the host machine. So we can extract the various features from the network traffic, and we can use the various machine learning classifiers, and we can use those features for the malware classification. So this API call traces, again, it's a we can trace for the accessing the file systems, devices, processes, threads, and error handling, and we can access the various functions that Windows registries, user accounts. So this way, various authors have used this API call traces also as a feature for that machine ML based classifiers. So just one example, we'll discuss that how we can implement that malware detection with the malware using that ML based techniques. So we just take that malware and the benign binary files. We can extract the various features, and we can go with the pre-processing, and then we can just divide that data into training and testing set, and then we can give that training data set for the training of the machine learning model, and we can detect that whether that malware is a benign or malicious. So this various data set is available in that malware also, in that Kaggle data set also. So you can download that malware data set, and you can just analyze it, or you can implement that for the malware detection. Just a minute, one example that I have taken. So my screen is visible.
Yes, ma'am.
Okay,
Yes.
okay. So this example just I have taken is, it's a very basic example. This malware data set I have downloaded. So this is I have used a Google Colab. So just you can mount your Google Drive by this command, that is from google.colab import drive, and we can mount our Google Drive. So after that we can just import our files. So we can upload your file that is in that your Google Drive. So here I have taken that malware data set, and that data set name is the malware. It is a CSV file, and after that we can import that pandas and that numpy and numpy various libraries, and then by using this after this we can just read this CSV file and store it in the data set. And then if you want to know about that what are that various contents of the file, so we can just extract that head of the file. So it will show you that first 5 rows or first 5 instance of that data file. And then suppose you want to find that last 5 rows, then we can use the dataset.tell command. And suppose you want to know about that various columns, what are the various features are there. So these are that various features are there in that malware dataset. So these are the P based features. That is the name of that file, eMagic, that is a magic number or signature, size of the optional header, number of symbols, number of sections, time, date stamps. So all these are the features that is extracted by this static analysis and by using this P file header. So this with the dataset dot column, we can extract. And then suppose you want to just find a summary of the numeric attributes, then just use the describe command. That is a dataset. The dataset we have already stored. So dataset dot describe, it will include all that attributes. So here it will find that count, unique value, or the top value, frequency, mean, standard deviation, and then 25% data, 50%, 70% maximum of all these numeric kind of value. So here we can find a summary of the numeric attributes. And then we can find this dataset info by using this command, that is a dataset info command. So it will just mean that what kinds of features are there, what is that their properties. I mean, it's a numeric type or it's a integer type or float type. So this we can find with the help of this dataset summary, dataset info command. After that, we can just count that how many malwares are there and how many benigns are there. So here we can check that dataset malware dot value count. So we are just counting that how many malware is there and how many benign files are present in our dataset. So where malware is a 14,559 and that 5,001 benign files are there, and it's a integer type. And we can plot with the help of this matplotlib, that pie plot. So just import this matplotlib is a pie plot is a plot, and that data set that benign and this benign and that malware count, we can just we can display, or we can use that other kind of plot also, that a bar graph or other chart also we can use. So here it's a pie graph we have used. So now another one is that name. We have to just drop these two things because there's a no use of name, and that we have to extract this malware. So malware feature, it is a labeled one, or it is a in this malware feature it is given whether it's a file is a malware or benign. So we have to extract this malware. So just this label, data label, we are just extracting and we are storing into Y, and name and malware are extracted from that our table, and we have stored in that X. So here that label data is stored in the Y, and that all that instances, all other data are stored in that X variable. Now we can import that various libraries. That is a yeah. After this, we can import that various libraries. That is a pickle libraries. Basically, it is used to convert that Python object into a byte stream to and store it in a database or files. And the cburn we have imported to just import that just to see that various data visualization library. Maybe you might be knowing about all the things. So this is a data visualization libraries to visualize the data. So this cburn we have imported, and then matplotlib for again for the plotting, and that for the various machine learning classifier, that we have imported this sklearn library, a scikit. So here that is first that machine learning model is a random forest classifier. So from this sklearn we have imported a random forest classifier, and that for the model selection, because various kinds of model we can use at either a trend test model, a trend test split, or k-fold, or one leave out. So various models we can use. So here we are using the trend test split, and then to just we have just imported that matrix for the classification report, and to display the confusion matrix. So now in the trend test split, we have divided our that x and y that we have already stored here, as a 20% test data and 80% that training data. And we have stored in the Xtrend, it will be training data for all the features, and Xtest for the testing, and Wiretrain for the training of the label data, and Wiretest for the label data for testing. And after this, we can just go with the pre-processing. So in the pre-processing, here that Z score we can compute, and we can just scale down. We can just transfer, because that ranges of that numeric value may be that different. So we can scale down in form of 0 to 1. So by this method, that is standard scalar, and we can just transform it in that both I mean the training data set and the testing data set. And then here that in another one is that KNN classifier. So in the KNN classifier, basically that again we have to import that KNN classifier if they scale on. So here that various parameters that we have given. So here that we have already run this. I have already run this. Just a minute, I'll show you that. This one, this is a random classifier that we can run this, and we can see the result. Actually that I have run it earlier. So again, I have to import all the things, then only it will run. So it will take time. So this is just an idea I'm giving you. So here again, we have to import my data set, and then it will run, because it's a Google Colab. So just I'm giving you an idea. And then that KNN classifier we can use. In the KNN classifier, we can use the number of labels, and then distance matrix, that Euclidean distance or checkerboard distance or any other distance, and power. Basically, we use a power up to. So first we can define the classifier, and we can fit the classifier with the training and testing with the training data, and then we can predict the test result. And we can just find that a confusion matrix, and then we can just display that confusion matrix of the predicted and true labels. So here that result, we can see that when we have just run this program. So here 960 benign files, 960 benign files are just detected as a benign, and 44 benign files are detected as a malware. So it's a true positive. So here in this case, that 28475 2874 files are detected as a malware, and 45 files are detected as a benign file. So it's a true negative. So here this we can just display that result in terms of that confusion matrix, and in terms of that precision recall, or this F score, because our data is a balanced unbalanced data. That's why that we need to find that F1 score also. So similarly, we can use other classifier, that random forest classifier. Yeah, here we have executed that. So in case of random based classifier, again we can find a precision recall and F1 score, and then we can display the result as a confusion matrix. Similarly, that we can use that AdaBoost classifier, or and then we can use that SVM classifier. So all these things are already available. Maybe you might be knowing. Just I'm giving you an idea that how we can apply that malware, different machine learning techniques for that malware detection. And we can use a neural network also. So here the TensorFlow we have imported, and that sequential network, that is a complete network, a neural network we have built, and we have used this for the malware detection. So these things you can, and this is for the, suppose you want to find that AUC, area under curve, by plotting this ROC, then we can plot this ROC also. So this is just an idea that how we can use that machine learning features. I mean, how we can use that various features for the machine learning technique for the malware detection. So similarly, that we can use that malware images also for the detection in classifier. So what we can do, that we can just convert that malware data into grayscale image, and we can apply the image normalization and various image processing techniques, that noise removal or that enhancement techniques, and as I told you that the taxers will be different. So we can extract the various taxer-based features, and we can create a feature vector, and we can apply the machine learning and deep learning techniques for the classification of malware. So here that suppose this is a binary malware input, so we can just we can convert the binary to 8-bit vector, and this 8-bit vector, because 8-bit will be represented as a 1 pixel, so that's why we are just converting into 8-bit vector, and we can find the grayscale images. So here that various families of that images are there, various malware families, and their sample grayscale images are already available. That is a ramnit. It's basically a is still a sensitive information as a username and password. So we can see the taxers, so same family, the taxers are similar. Lollipop, it's a kind of malware, it's adware, basically it shows ad in our browser and redirect the search engine result. So we can see the taxer of Lollipop is different than the Ramnit. So window is again a chooser, it causes a pop-up and advertising for the anti-spyware program. So we can see the taxers of all these images are different. So similarly, that SIMDA is there. That is a backdoor malware. It again try to steal the sensitive information. That is a username and password. And Trakur is there. It's a Trojan, and that Calihos. So already this grayscale image data sets are available. If you want to use those data sets for your research purpose, you can use that upscatter.acy. It is obfuscated one to hide their purpose. And that Gatak is there, that is a Trojan that gathers the information about a PC and sends it to the hacker. So when we analyzes that these grayscale images, their taxers are different. So we can just extract the various taxer based features, and we can use those taxer based, already that various authors they have used, and we can use those taxer based features for the malware detection and for the malware classification. So these various malware image data sets are already available. That in the Kaggle also it is available. That is a mal image, that 9,342 sample images are there, and 25 different classes of malwares are there. So these are some samples. And big 2025, it's a tag challenge. It comes. This data set is already available in Kaggle. So here 21,741 images are there, and number of classes are 9. So again, as I shown you that various different types of malware families, that Ramnit, Lollipop, Window. So these 9 type of malware families are there in this big 2015 data set. So Umber is there, that is a feature extracted from 1.1 million SPE files. So this is also available in Kaggle. Blended is there. So in the blended, this malvis and then mal images in both are combined. So here that total 31 types of classes are available, because some of the classes are common in that mal images and then malvis. So they have just combined this, and they have blended it as a single data set. So Malvis is again here that 14,226 images are there, and number of classes are 25. So as I told you that taxers are different in these grayscale images. So this is again a pipeline. We can give that malware images an input. We can apply the various image pre-processing tasks that people have already discussed in the last 3 days. What are the pre-processing we can apply, that normalization and filtering. We can extract the various taxer based features, and then we can create a feature vector for training and testing, and we can apply the various classifiers for that malware detection. So that various taxer based features, that is a Gaber features, Harlick features, local binary features. Harlick feature is a GLCM feature, that is a gray level coherence matrix. So we can just compute the various Harlick based features. So here that 18 features are available. The Gabber features also we can extract the various taxers, local binary pattern features, and we can just convert that grayscale image that features. We can reduce the dimensionality of those features by using the PCA, and that wavelet is also a taxer based feature. So we can extract the various taxer based features, and various authors they have already used those features for the classification. Nowadays in this era, that it's the era of the deep learning or convolution neural network, so we can give this malware images as an input to that convolution neural network, and then and then we can classify those images. So the convolution layer, and then ReLU activation function we can give, and then pooling. So you might be aware with this deep learning or CNN model. So we can apply this also. I think one I have actually that it takes time, so that's why I have not executed that one, but it is there in that. So same way. Yeah. So here in that, by using this PyTorch, we can just use that CNN model or deep learning model. So here that we can import the torch and torch vision library, and that because we are using that CNN, so torch.nn as a function. So these various libraries we can import, and then NumPy, matplotlib, time, and then various libraries we can use, and then we can run for the detection or classification of malware. Again, that I've imported that drive, and that actually this image is a zip one, so we can unzip it by using this unzip command, and then we can just split the folder as a training and testing. So we have splitted that folder in the training and testing. So split folder is there. So here that ratio is 80% and 20%, and then we can just divide that training and testing data, and we can store in a different folders, and we can check how many train images are there, how many test images are there, how many malware train images and benign train images are there. So that training and testing folders, we can split the images, and again we can transform it, we can resize it, and we can normalize that images by using this transform.resize and transform.normalize command. And then we can train, we can just uh, 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 take that data into train in well variables, and we can load the data, and we can just set that various batch sizes. Here that batch size is 128. We can just change these batch sizes, and then that various classes, that malware and benign classes are there. So we can just extract those classes in classes variables, and here this we can see that images, what images are there and how it looks. Because it is taking time, that's why I'm not executing it, because again it will extract it. So we can just take that various batches of data, we can show that images, and we can just define the neural network module, that what how many layers you want to take, that batch sizes and all, that linear and non-linear, that various activation functions. So this is that it defines the init, it defines that the linear model, and then a linear layer, and this forward it defines a non-linear, what that various activation function that you are going to use, and then dropout layer. And suppose that CUDA is available or CPU is available or not, that we can check. If CUDA will be there, then it will run on the CUDA. And then again that we can find the summary, and then we can just see that what is that structure, how many layers were used, what is the shape of that neural network. Okay, so this thing, and we can train our model, and same we can just find the result, these parameters. So CNN nowadays at various, this is a basic CNN, but you can apply that various other CNN models also. And various authors, they have used that various deep learning based models for the classification and for that detection. So I have studied, I have gone through that various that papers. So that limitations and challenges, what I found that there is a unavailability of the reliable data set. So we can suppose we want to train our model with the real time data set. So we have to check that whether that data set is reliable or not. Suppose we'll get the data set from the net, so we have to check whether it's reliable or not. So that publicly proven data set we have to find, and we have to for the suppose we have any malware, so we have to go through that static or dynamic analysis, and that is also, that will also be a challenging task because it takes time. And mostly most of the works has been done for the detection. So in the classification, various classes are available, like as I told you, the 9 classes, 25 classes, and 31 classes. So for the classification, more data set will be required. So if you are interested for the research for the classification, very less work has been done for the classification. So this you can go for the multi-class classification of the malware. So many existing works are there, as I've already shown you that various authors, they have used that various input features. That PE file is the input features, and they've given that into a SVM model, and the different ML models, the decision tree, random forest. These are by using the byte engrams. So this author Santosh, he has selected the top 1000 features from the 1 or 2 gram code and trained the HPM malware classification. So various authors, they have used the different kinds of features, and they have applied that various models. This thing we have already seen, just that I want to show that various existing works. So that link is also given. This author that Gyasi, he has monitored memory content register values, and he has invoked the API calls. So various author, they have analyzed the traces of output. This thing we have already seen that. This is the same thing. So here this is a research gap. So we can go for the multi-class classification of the malware using images. We can just analyze for the multi-model data. So that is, we can just various authors, they have used a single static features. Okay, like P features or API call trace or memory content only. So what we can do, that we can just combine that static features as well as the dynamic features, and we can create that multi-model data, and we can use that multi-model data for the malware analysis. So that will be a more effective. And nowadays there is an era of that deep learning model. So that we can apply the hybrid deep learning model for the malware detection and classification. So these various references I have taken for this. Thank you. Thanks a lot. So if you have any query, then we can go to that query.
Suresh, do you have any question? You can unmute yourself. You can ask your doubt. Otherwise, type it in the chat box. Dear participants, if you have any queries, you can post either chat box, or you can unmute yourself. You can ask to the resource person. Okay. If no more doubts, yeah, it's fine. Thank you, Dr. Kanchanlata Keshav ma'am. It's a wonderful session, very informative. Uh, very easy to follow the lecture. It's very understandable one. Thank you so much, ma'am, for your valuable talk.
Thank you, sir. Thank you so much for giving me opportunity. Thanks a lot.
Thank you. Yes.
Okay. Okay.
Thank you. You can stop sharing. Yes. So participants, the next session will resume at 11:45. So in group, I will share the certificates of soft copy, right? PDF format I will share. If you have any queries, if you have any correction on the name or institute name, you please put message in the chat. Okay, WhatsApp chat. Okay, fine. Right. Right. Fine. Yeah. So after your name and college and institute names are fine, then I'll go for getting signed. Okay. Thank you. Welcome back to day 5, second section. Uh, this session is going to handle by Dr. Manikandan, VM, SRMAP. The topic is data hiding method for digital image security. It's my privilege to introduce Dr. Manikandan VM. He is currently working as an assistant professor in the Department of Computer Science and Engineering at SRM University, AP, Andhra. Before that, he was associated with IIIT Kottayam. He did his MTech in software engineering from QSAT, Kerala, and his PhD in computer science and engineering from IIIT DM, Kanjipuram. He has more than 13 years of experience in teaching and research. He published 75 research articles having international repute, published 14 Indian patents, and also having an ongoing DST self-funded project. His, his recent research work is focused on reversible data hiding, digital image forgery detection, and content-based image retrieval. Let us join with me to welcome Dr. Manikandan VM. Welcome you, sir. Over to you.
Yeah. Thank you so much, sir. Thank you so much for your kind introduction. So I will share my screen.
Yes.
I'm audible, right, sir?
Yes.
I'm audible. Yeah. I will share my screen also. So hope it is fine.
Visible, sir.
Yeah.
Is it the first slide?
No. I will move to the first slide. Just give a minute, sir.
Okay.
Yeah.
Yes.
Yeah, thank you so much, sir. So very good morning to all of you. It's a honor to be here today to interact with you. I want to talk about the data hiding methods for digital image security. So let us move forward. And since we have less number of participants, maybe it need not be a formal kind of discussion. You can ask any question. You can put it in the chat box also. I will try to take on the fly. Yeah. So today, since we have people with a different background, I just want to start the discussion by talking about some of the basics about the digital image representation. Then we will try to see what is digital image security. Then slowly we will move forward. Our agenda is basically we want to talk about the data hiding methods for digital image security. So we will try to see what way we can use data hiding methods for providing digital image security. And further, I want to discuss something called reversible data hiding. It's an interesting area we can explore further as part of our research and all. So I will try to discuss one specific algorithm also. It's not very recent, but once you understand this particular algorithm, maybe you will appreciate what is reversible data hiding. Then possibly if you have time, I will try to maybe some quick go through we can do on some MATLAB implementation also. I have a code with me. So if you have time, we will try to go through that and we will try to understand how these algorithms can be implemented using MATLAB. Yeah. So let us move forward. You can stop me at any point of time. You don't want to wait until last to discuss anything. Or if you can put query, if anything, in the chat box also. I will try to take it. See, some of you have some basic idea about digital images. Okay, so basically, a digital image is a visual representation of a object or scene that we can store in a computer. Of course, we can see in some screen also, or we can display it like in a monitor or in some devices, we can see those images also. So if we see a digital image, basically we can say that a digital image is a collection of pixels. Okay, so each small element in a digital image, we are calling it is a pixel. Pixel is the short form of picture elements. So what these pixel values will be indicating, that might be some color values, or it can be some brightness of different color. So if we see, to understand the whatever the topic we are discussing further, to understand that in a better way, let us see what all are the different types of images we are having quickly. So you can see here, there are 6 images are there. If you observe carefully, whatever the images in the first row, okay, you can see these images almost having the same information. So these are basically some of the well-known image. We are calling it as Lena image. Those who are working in image processing, they are very much familiar with the Lena image. And whatever the images in the second row, that we are calling Pepper's image. It's not exactly, okay. We are calling it as Pepper's image. So whatever the images that you are seeing in the first column, you can see that we will get some information from these images, but if you observe carefully, you can see that it contain only pure black or white, no other information. Okay, so that type of images we are calling, they are the binary images. What do you mean by binary images? In binary image, we can represent only pure black or white, only 2 choices, black or white. And the second category of images we are calling, they are grayscale image. Okay, so grayscale image means you can see that we can see more information as compared to binary image in the grayscale image. So generally, in a grayscale image, we will be representing pure black to white, different shades we can represent. Pure black to white, different shades. Okay, so like a different gray shades we can see. The third type of images, that is in our daily life, we are more commonly using color images. Color image will be having all the color image properties. Each pixel will be having a color information also. Now, you know, like our old black and white TV, we are calling them black and white TV, but they are not actually pure black and white. We should, if we, after seeing this, we should call them basically grayscale, right? Old black and white TV, it's not either black or white. We can see different shades from pure black to white. Okay. So, yeah, so let us move forward. I just want to give few more information about this image representation. So this is a binary image representation. Whatever you are seeing here, I can say this is a binary image. You can consider a binary image as a 2D array, okay, or a matrix. You can call it as a 2D array, or you can think of, you are familiar with the matrices. We can consider a binary image as a matrix, okay, and it will be having a specific number of rows and columns. It will be having a number of rows and columns, and each value in this matrix we are calling
See, within a minute, sir will join. Sir have some issue, some technical issue. He will join within a minute. Okay. Pinju, Hari, make Saras, Manigan Saras.
Yeah, I'm back. Sorry. Sir, can you give the screen share?
Yeah, 1 minute, sir. 1 minute.
Yeah,
That's what
yeah.
I'm telling. Hari. One minute, sir.
Yeah, fine, sir.
Yes, sir. Now you can.
Yeah.
Yes, sir.
Okay.
visible.
Yeah. So I was trying to discuss about the different types of images. So basically we have three type of images: binary image, grayscale image, and color image. Now, a binary image you can consider as a matrix which contain the values either 0 or 1. So the value, the pixel value 0 will be representing pure black, and maybe the 1 will be representing pure white. So if you consider an image here, I think we are having around 8 rows are there here in this image, and we are having 9 columns. So I can say that whatever the image we are seeing here, it's a 8 into 9 size binary image. And if you try to display the binary image using some computer display, we will be able to see an image like this. The ones will be displaying as white, pure white color, and wherever we are having 0, which will be black. Now, if you see the grayscale images, you can see a grayscale image again we can consider as a 2D array or a matrix which contain the values. You can see different values here. You can see some zeros. If you see here, yes, we are having zeros here in this locations. Okay, so what happening when you are trying to display a grayscale image with these pixel values? The zeros will be representing as pure black color. Okay, and you can see some pixels with the value 255, or if you come here, you can see the white pixels. Okay, so this pixel is represented using a value 255. Okay, and you can see other values between 0 to 255. If you consider this pixel or this pixel, the second pixel, this value, what is the property of this one? You can see it is 50. It is very close to 0. So you will be seeing it's as a gray color, which is having more black component. Okay, which is having more black component. So if you consider any pixel value with a 245 or 240 or something like that, then what you will be able to see, you can see it will be very close to white, but not pure white. Pure white will be represented using 255. Now, why this range varying from 0 to 255? Whether it must be always 0 to 255, or can I have some higher range? Or why I have taken this 255 as the highest value? Can anybody answer that question? Why we are keeping 255? What is the specialty of 255? Why I can't keep 257 or 300? What is the specialty of the value 255? Can anybody take that question? You can put it in the chat box. 255, maybe you can, as a computer scientist, or we can consider it as a special number. It's having some special property. What is it? Anybody want to answer that question? Yeah, great. Yeah, thanks for answering the question. Yeah. So basically, we need to store this kind of images in a computer, right? So each pixel value we have to store. Whenever I want to store an image, I supposed to use certain number of bits for each pixel. So generally in a grayscale image, you will be using 8 bits to represent each pixel. So if I'm having 8 bits, what is the maximum pixel value I can represent? If I'm using a 8 bit, I can represent 8 ones. 8 ones in 8, like 8 ones I can store it in a 8-bit memory location, right? The corresponding value of 8 ones are nothing but 255. Or I should say that it is 2 power 8 minus 1. So it is not mandatory that all the grayscale images must be the value 255. But generally, the human eye can recognize the pixel values from this many shades only they can recognize generally. That is the reason 8 bits we are using to represent the images. But if you see some medical images and all, we are going for 16-bit grayscale images also. Okay, so in that case, if you are using 16-bit to represent each pixel value, then you will be having a wide range of grayscale values. It will be vary from 0 to 2 power 16 minus 1. Okay. Yeah. Now, if you see, basically in an 8-bit representation, the highest integer value that we can store is nothing but 8 ones. 8 1. If you convert 8 ones to an integer value, it will be 255. Okay. Yeah, good. Now, if you take a color image, what will happen? In each pixel, you will be having 3 different color components. So one of the common image representation is RGB image representation. There are different other image representation also there. Okay, but one of the common way of representing color images are RGB representation. In RGB representation, if you take any pixel from an image, that pixel will be represented using 3 different values. Actually, whatever the value you are seeing here, 100. Here you can see 30. Here you can see 201, right? So these 3 different values are representing 1 pixel value. Okay. So, like we studied that we can mix different colors, primary colors, and we can try to create new colors, right? That's what happening here. You are trying to take a certain amount of red. Okay, you are trying to take a certain amount of green, and you are trying to take a certain amount of P also. To mix, you will get a new color. That will be the corresponding color for that particular pixel. Okay. Now, we have different types of images. We already got to know that, which all are the binary image, and the other one is grayscale image. The third one is color image. We are very much familiar, or we are daily life, we are very much familiar with the color images. Okay, but generally, the people who are working in any image processing domain, they will be considering the grayscale image. Okay. So what is the reason? Should I only consider the grayscale image? It's not like that. Okay, it's not like that. Since if we are considering a grayscale image, basically, if you develop any algorithm for a grayscale image, then you can easily extend that into color images also. Because I can say that a color image is just like a three different planes. Okay, three different planes. Each plane will be similar to a grayscale image. Okay, why we are having three different planes? One is red, one is green and blue in a color image. So maybe whenever I told at the beginning, I will try to discuss some basic algorithm. So we will try to consider grayscale image as the input image and we will explain. Okay. So if you develop any algorithms for grayscale images, we can easily extend that into color image. Okay. Okay, let us move forward. Now, our agenda, we want to try to connect with image processing and image security. Okay, so what is the term image security stands for? Basically, you can call image security is a set of activity, okay, that we are using or that we are following to avoid unauthorized access of images, okay, or unauthorized tampering of images or illegal distribution. Okay, many activities. It's not like we can't define exactly this is what image security. Image security generally it is trying to introduce or it is taking care of a set of activity which will ensure that the images are not illegally modifying or it is not illegally distributing by the people. All this set of activities we can consider as image security. So if you see the image security domain, we can see two basic approaches. Okay, two basic approaches. One is image encryption and the other one is data hiding methods. Okay, of course, I'm just trying to give an overview. We can, if we go in next level, we can see many other methods or solutions for providing image security. Okay, in the top level, as a beginner, I can say that there are two approaches are there. One is image encryption and the other one is data hiding methods. We are familiar with the term encryption. We are familiar with the term encryption. So what is basically encryption? Whether anybody heard about encryption? Some of you people might be working on encryption, right? Before moving forward, can anybody answer what is image and what is just encryption? You can put it in the chat box. Anybody heard about encryption? What is the purpose of encryption? Anybody? You can just try to answer. Very good. Yeah, I can't see the name RK. Okay, good. You're right. Anybody else want to answer? Okay, basically, when we are talking image encryption or just encryption, the first word coming to our mind is security. Okay, so the process, the encryption process is basically trying to convert. Okay, let us assume that I have an image. We are talking about image encryption. I have an image. What I will try to do, I will convert that image into in unreadable form. Okay. Yeah. Jilna, I got your answer. Converting to a intelligible form. Okay. Makes sense. Okay. So image encryption process, what we are trying to do, we have an image. We are trying to convert into another form. Okay. And if you see that transformed image, you will not be able to get any information. You cannot infer what it is. For example, I have taken my image. Okay. And if I see that image, okay, this is my image. Okay, fine. Now, once I apply some image encryption process on this, you will not be able to see any information on the encrypted image. Okay. Then how we can use it for future? See, whenever we are using an image encryption, what we will try to do, we will try to use an encryption key. Okay, we will be using an encryption key. Okay, so let us assume that this is an original image and I am having an encryption key. And what we will do, we have a number of image encryption algorithms. The image encryption algorithm will take two things. One is original image and the other one is encryption key. And what it will generate an encrypted image. If you see this encrypted image, can you infer anything? No. Encrypted images, generally it will be like a texture image or a complete noise kind of information only will be there. You will not get any information from here. Okay. Now what you can do, if you are very much concerned about providing some kind of confidentiality means you don't want to expose what the content is there in your image. Okay, what you can try to do, you can try to apply image encryption. You will get an encrypted image. Then what you can do, you can transmit this image into another person. Okay, or you can try to store this information in a cloud. Okay, nowadays we are using cloud storage to store our data, right? This cloud storage is running by some third party. For example, we are using Google Drive. Google is owning the Google Drive, right? Whatever the data you are uploading, there is a possibility the Google can access it, right? Yeah, but let us assume that I have some private confidential data with me. I'm uploading into Google Drive and I want to make sure that no one should use it. What I can try to do, I can try to apply some encryption and I can try to upload there in the drive. Then no one, the cloud storage service provider itself will not be able to view what is the content there. Okay. Yeah. So now, see, the encrypted image will look like this. You can send the encrypted image through network. And what will happen whenever you want to get back the image, you will be using an image decryption algorithm. You will take the encrypted image and the decryption key also as the input. So where we are providing the security? This is like a password of your laptop. Okay, or this is a private key that you are holding. Those who have this key information, they can only be able to decrypt. Once you decrypt, you can see the image. Okay, is it make sense? Yes. So this is the process of image encryption. We are converting an image into a unreadable form. Okay, when we are talking about simple data encryption, forget about image, then what you will be doing, you will take a message may be something like hello, good morning. That can be a message, right? Once I encrypt that, in that text you will not be able to understand anything, but whenever you are decrypting it, you will be able to read the message. Okay, so I hope you are following. Let us quickly try to show, there are some random web pages are available. They are simulating the image encryption. I just want to show quickly in a minute so that you will get a better idea. Okay. So if you see, this is one website you can see. Somebody developed it. I'm not saying it's a professional website, but you can see how image processing is working. Can you able to see my screen? Can anybody respond in the chat box? Other than PPT, are you able to see a new web page? Yeah, thank you, Jilna. Yeah, so you can see here, I can just try to add an image. So in desktop, I just downloaded a couple of images. Maybe I'm having some image called army. I'm trying to select that. Now you can see the password here. I'm going to give some password like maybe triple IT K, triple IT K 123, something like that. You can use any password. Okay. Now, if you try to click encrypt, you can see that what I did, I selected one image here and I have given a password also here. So this password is nothing but an encryption key. Okay. So now if you click encrypt, then what's going to happen? You can see that the platform is generating the encrypted image. Okay, and see, we have a number of encryption algorithms already in use. Okay, there are number of encryption algorithms. Okay, actually, I'm not aware what kind of encryption process these people have done. Maybe some basic simple encryption process they have done. Okay, so but our ultimate objective is we want to understand how the image encryption will work. You are taking an image, you are considering one password or encryption key. When you are asking the algorithm to encrypt, you are getting something like a noise kind of thing. You can, whatever you are seeing in the right side, that's basically a encrypted image. Now what you will try to do, you will try to download it. Okay, you can try to download it. Yes, this whatever the image you are seeing, that is basically an encrypted image. Okay. See, now you have the same option. For example, if you go back into the here, in the same platform, they are providing the decryption also. Okay. Whenever you want to decrypt, what you have to do? You have to select the encrypted image, whichever you downloaded. I'm selecting that. Okay. Now you want to, whichever the password you have given, you should be keep it in mind. I have given IIIT 1, 2, 3. So try to give IIIT 1, 2, 3. Okay, I will try to decrypt it. Hopefully it's supposed to work. Yes, it is working. You can see the decrypted image. Okay, so what you can do, even some simple image you want to share with your friend, you can use this platform. You can just encrypt the image. Okay, you download it, encrypted image you can send to your friend. And if you share the secret key privately with him, okay, then he can decrypt it whenever they need. Okay. So let us try, if I try some other password, sometimes what will happen? We don't know the exact password, right? I will try to decrypt with some wrong password. I'm trying to give IIITK 234 as the password. I will try to decrypt it. What will happen? No, I'm getting again completely noise kind of thing. Okay, so unless if you are not able to give the correct password, you will not be able to restore the original image. Okay, so this is the basic of image encryption and decryption. I hope you are following. You can think about, or you can explore your further work. Try to study what all are the existing image encryption and decryption algorithms available. Okay, and how you can improve it. It's an area where you can work in future. Now, another important concept that can provide the image security is data hiding methods. And data hiding methods we are using in two different ways. One is steganography and the other one is digital watermarking. Okay. So what is steganography? Steganography is very old terminology, maybe at least 30 years old. Okay, 25, 30 years old terminology. So it will be easy for me if I give you an overview for steganography. Then when I'm discussing about something called reversible data hiding, you can follow the concept in a better way. Okay, so what is steganography? The idea is very simple. I want to send some data securely to my friend. Okay, what I'm going to do, I'm going to use something called a cover image or a cover medium. Okay, you can see an image of a innocent baby I'm using as a cover image. Now, I am not much interested on this image. Basically, I have a very crucial information. What is that? This is the username and password of my internet banking. Okay. I just took a random example. You don't try this one. This will not work. Okay. So I have a username and password. I just want to share this information with my friend, let us assume. So I can try to use a steganography scheme, which will take a message and a cover image. And what it will try to do, it will try to generate a stego image. Now, in this stego image, you can't see that there are some hidden information. Okay. For example, you are ordering something from Amazon, right? What will happen? You are ordering a mobile phone from Amazon, let us assume. They will do some nice packaging, right? If somebody, the courier person or your neighbor, whenever the product is delivering, they don't have any idea what is there inside the product. They can only see the package. Okay. So that package is nothing but the cover image. And we are not at all concerned about the packaging. Okay, we are concerned about the product within that pack, right? So that product, nothing but the data, secret data that we need to communicate. Okay, and once you get a Amazon delivery, what you will do? Okay, what you will do? You will unpack it. You will take the mobile phone and you will throw your cardboard boxes or whatever you are having, that package, you will throw it, right? The similar thing is going to happen in steganography also. The stego image, the receiver will get the stego image. Okay. What they will try to do? They will extract the hidden information and they will just throw the cover image. Okay. They are not at all concerned about the cover image. So this can be used, the steganography schemes can be used with some good objective, or people can misuse privately to some people, right? Okay. So, but you think about this concept is using by some terrorist. They want to send some mission, their mission. Okay. To there are two activities are parallelly, and there are some people they are trying to do steg analysis. Steg analysis in the sense, if I give you this image, okay, I want to know whether any hidden information is there or not. Okay, forget about the hidden what exactly there, but whether any hidden information is there or not, I need to detect. Okay, so that process we are calling steg analysis. Okay, so that is also exploring. The steganography schemes can be used with some good objective, or it can be misused also. Maybe I can quickly show you one quick demo also on steganography, then you will appreciate how we can use it in our daily life. Okay, so this is another web portal. I was searching for some steganography portal. You can see here, you can select an image. I downloaded a couple of images. Maybe I'm having a image called baby. I'm just selecting that image. Okay, you can see here. This is the original image, and whatever the message you want to send, you type here. Maybe username, money VMK, and the password is something like maybe IIIT K 12123. Okay, yeah. So now if you come down, you will be able to see. Okay. Yeah, it's taking some time to load. Just take the image, select the thing. Okay. Yeah. So just give the message. Username is here. I'm giving money VMK, and password I'm giving maybe IIIT 123. Okay. Now you have an encode button here in the right side. If you click encode, what will happen? You can come here. You can see this is the image. Whatever at the final you are seeing, this is the stego image. Stego image means already we are having the hidden information in this one. If you see the original image and the stego image, there is no much difference. Okay, only few pixel values you changed. That will not affect the quality of the image. Okay, and this process actually, the normalization is a image enhancement technique. Okay, which will ensure that whatever the image finally you are getting, which will be having will not be having any visual degradation. Okay, so normalization is a image enhancement technique. So they are just trying to apply some image enhancement, then they are doing the data hiding. Now what you can try to do, you can just try to save this image and you can store wherever you want. You can save it as something called a stego image. Whenever you can share that stego image to your friend, and whenever you want to get the actual data, okay, what you can try to do, you can try to upload it here, and you can try to do the decode. Okay, so you can see that the username and whatever the embedded information you will be able to see here, username and password. Okay, password is IIITK123. And from the remaining pixels, they embedded some invalid character. There is no active character, but you will be able to see the actual message, hidden message here. Okay, are you people are following? Can anybody respond in the chat box? Are you following? Jilna or RK or anybody can just respond. Everything is fine. Yeah, thank you, Anne Small. Yeah. Yeah, it's good. Let us move forward. Okay. See, another one topic related to data hiding is basically steganography, in which what we are trying to do, we have a secret information. We are trying to embed that information in a cover image, and we will get something called a stego image. Okay. The receiver, what they can try to do, they can extract the message. They will just ignore the cover image. Okay, they are not worried about the cover image. They need the hidden information. Okay, so the next thing, something called a digital watermarking. Digital watermarking is another data hiding technique which we can use to provide digital image security. Okay, so I can say that digital watermarking can be classified into two types. One is visible watermarking and the other one is invisible watermarking. Okay. So what is visible watermarking? We are very much familiar with the visible watermarking. Whenever you are trying to watch the movies in some TV channel, you should be able to see the channel logo, right? I can say that it is a watermark. What is the watermark? The TV channel logo will be coming as a watermark in the video. Now, what is the benefit of that watermark? See, let us assume that I am watching the some recent movies in Sun TV or Surya TV. Let us assume. What I can try to do, I can record that movie with my mobile phone, and I can re-upload in YouTube or somewhere, right? Or I can use some TV recorders in my setup box. I can redistribute it illegally, right? It's not basically a legal activity, right? So if I do that, how could we able to catch the people? Maybe with this logo, we can realize that these people are misused. This is actually not their content. Okay. Yeah. Of course, people will try to remove this watermark using some of the image processing algorithm. Okay. Then what they will try to do, they will try to redistribute it. So if you see some of the websites, okay, some of the websites like this one, Shutterstock or Adobe, iStock Photo, these are some of the web portals where you can purchase the images. Okay, have you come across any of these websites? Basically, if you are a freelance photographer, you can capture some of the nice images and you can upload the high resolution images in this web portal. And what you can do, see, let us assume that somebody looking for some images to design a flyer or to design a flex board on some event. They need some high resolution images, let us assume. They can come here and they can purchase it. For example, I'm just trying to search something like badminton. We are going to plan to conduct a badminton tournament. And what I need basically, I need to design a flyer related to badminton. Okay. Now what I will do, I will search the keyword. I can see a nice high resolution image here. But can somebody tell, can I use this image as it is, or do we have any concern here? Anybody? Any quick answer? You can try to put it in the chat box. So shall I take a screenshot of this image and shall I use it, or I will try to save as image or something, then I will use it. But do we have any real concern here? Anybody? Yeah, you can make an attempt. I think what is the issue if I can if I take the screenshot of this image and I will go for designing my flyer? Do we have any concern? Yeah, quickly you can, like WhatsApp message, you can write the answer. Some short answer you can write. Yeah, yeah. Thank you, Dr. Pakiraj. Yeah, I got an answer. Yeah. So you can see there is a message like the Shutterstock, right? So this is there. This indicates that this belongs to Shutterstock. Okay. And if you use it, one option is that you can try to remove this watermark information by using some editing tools. Okay, you can try to do that, but then you will not be meeting your objective. You can see that in many other image content is also here. If you try to remove this, of course, it is going to affect your image quality. Okay, of course, it is going to affect your image quality. Now, if you really need this image, what you have to do? You have to purchase the image from the Shutterstock. And Adobe Stock also, like the same way, you can try to select the image. Then if you open that image, you will be able to see the content with the watermark. Okay, this is very a semi-transparent way they kept the watermark. I'm not sure whether you can see that there is some very blurred way they kept Adobe Stock like that everywhere. So if you download this image, you can't use it as it is. Okay. Yeah. So this is basically visible watermark. Okay. Let us quickly recap what we discussed. Then I will move forward. See, we have some idea what is image security. Image security means it is a set of activity which will help us to ensure that an image will not be modified by an unauthorized person, or an image will not be illegally redistributed. Okay, or if there are some modification happened in an image, we want to detect that. These all set of activities which will support this objective, we can call they are image security algorithms. Okay, one of the important image security aspect is image encryption. Image encryption will help us to provide confidentiality. Confidentiality means an unauthorized person cannot see the content within an image. Okay. The other activities are like a data hiding method. We can call like steganography is one of the data hiding method. We can use steganography to embed some information and we can send it through some unsecure channel. Okay. Yeah. And other aspect is digital watermarking. Okay. Digital watermarking. Digital watermarking will help us to provide the copyright or ensure the copyright. Copyright means whatever the images is there in the Adobe website, Adobe is the right person, or they are holding the copyright for that image. No one else is illegally allowed to use it or distribute it. Okay. Yes. Now, I want to move into our core topic called reversible data hiding. Okay. Reversible data hiding means, you remember when I talked to steganography, I tried to connect the steganography with an Amazon delivery, right? Once you get the Amazon delivery, you will remove the pack, you will take the product inside, you will throw the package, right? You are not concerned about the package, you are worried about the content within or the product within the package. Okay. The steganography scheme, if you take the old steganography scheme, it is like that only. You embedded some crucial information in a cover image, but the receiver is not worried about the cover image. They need the hidden message. They will ignore the cover image. Okay. But reversible data hiding is an extension of steganography. Okay. And here, what we need, I will tell you, we are worried about the cover image also. Okay. And rather than the cover image, we need to restore or recover the original cover image. Okay. Yeah. See, try to understand this figure. It's a very basic information is given here. You can easily follow that. What kind of information is here? See, I'm having something called RDH. What do you mean by RDH? I kept the short form of reversible data hiding. Okay, reversible data hiding. Okay, so I have a RDH algorithm. What it is going to take? It is going to take an image. I'm calling this image is I. I'm going to take an image. I'm calling it is I. And I'm having a message. You can assume that the message is just a sequence of bits. Okay, because if you have a text message, hello, good morning. Of course, in the machine level, it is a sequence of bit, right? Yeah, you can consider this message as a sequence of bit, or you can assume that it's a sequence of character. You assume whatever you want. Okay, so we have a message here. We have a cover image. Now, RDH algorithm, what it will try to do? It will try to create a stego image. I'm calling this stego image is I dash. But the original cover image is I. Why I'm not using the term or using the notation I to denote the stego image? Can anybody answer that? See, I am considering a cover image I as the input image, and some whatever the output I'm calling it is I dash. I'm not calling I. What might be the reason? Anybody? What might be the reason I'm not using the same notation I to indicate I dash? Any quick answer? You're too lazy to type something? Anybody? Because anybody want to answer? Okay, fine. Let us move forward. So I dash, basically I want to say that the stego image need not be exactly like the cover image, because you are doing some operation here. Certainly there will be some changes on the cover image. So what you are getting, it's basically a modified version of I. That's why I'm calling it is I dash. Okay, that's why I'm calling it is I dash. So the operation, whatever we are doing here, I am trying to embed the message in a cover image. So the output image maybe I dash will look like the original image, but with some slight variation. Okay, yeah. So now where we can use reversible data hiding, and what is the receiver side, what exactly we are expecting. Now, to the receiver, you are going to send the stego image. The stego image you are calling it is I dash. Okay. And at the receiver side, you will be using something called a module. You are calling it is data extraction and image recovery module. Okay. And what is the objective? You will be able to get back the original image I as it is here, and you can get back the message also. Now, how this framework is different from conventional steganography scheme? In conventional steganography scheme, you are only worried about the message. You are not worried about the cover image. But in a reversible data hiding scheme, I am concerned about the recovery of the original image also. I need to get back the original image as it is. Are you getting my point? See, here you got I dash will be look similar to I. At the receiver side, what I'm expecting, I need to get back I as it is, the original image as it is. And I want to extract the message also, M also. Okay, are you following? Yes, this is the objective of reversible data hiding. But whenever first time I came across this framework, it's looked only imaginary, right? How we can do that? How we can get back the original I while extracting? Maybe I can extract the message, no worry, but how we can store I? Okay. So initially I thought it's completely impossible because we are doing some changes in the image, and how can I restore the original image as it is? Okay. So to appreciate this framework better, we will try to see some of the algorithm, or at least one algorithm. Yeah, I will be having around 20-25 minutes. Within that, I will try to discuss one algorithm. that is bit old, but once you understand the algorithm, you can explore further. Okay. Now, why we need something called a reversible data hiding? We already have some steganography, and we thought like only I am worried about the message that I embedded. And the conventional steganography schemes are allowing you to embed something on a cover image, you can transmit it, and at the receiver side, you can get back the message, right? Then why we want to think about a reversible data hiding, in which we can restore the original image also at the receiver side? Okay, so the application we can think about using RDS schemes for medical image transmission. Okay, let us take a healthcare environment. For example, we are having sometimes what will happen in a small hospital, some person will come with their digital medical reports. It can be a digital X-ray or MRI kind of thing, digital data, let us assume. Okay, now what we are going to do, they want to send this medical image and some of the patient report to another specialized hospital or to another expert doctor for a second opinion, let us assume. Now, one option is that I can send the medical image and I can send the patient report. This report may be, you can think about it's a Word file or a notepad file kind of thing, simple text file. Okay, these two things I can send as a two separate file. I can send. Okay, let us assume that Dr. Bhagiraj is a expert doctor. What I will try to do, I will try to send medical image and this patient report, two information. These two files I will send. And what he will do, at the receiver side, he can see the medical image, he will open the report, he can process it, fine. But like maybe if he is an expert, he will be getting many such images in a day. Maybe he is getting 500 images and patient reports in a day. It is very difficult for him to handle two different entities, right? Yeah, of course, if he is having some platform to handle all those things, it can be done. But the RDS schemes giving a space to us to use in the medical image transmission. What I can try to do, I can try to use reversible data hiding in this way. What I will do, I will consider the medical image, I will try to take the patient report, I will try to embed it in a medical image. Of course, when I want to do the embedding, I will be doing some changes in the image, right? That's why I'm calling it is the stego image. It need not be the original medical image. I'm going to transmit this image. Only one image I am going to send. I am not going to send two different files. This medical image contains both the patient report and the medical image information. I will be sending this information to the receiver. You can assume it is an expert doctor. What they will try to do? They will try to use a data extraction and image recovery module. They will extract the patient report and they will be able to restore the medical image also. So why we need to restore the image? Why I can't use the stego image as it is? See, if you had some knowledge on medical image domain, basically this medical image people are very much concerned about the quality of the image. Okay, because during the data hiding process, you might be doing some changes in the image, right? So there is a possibility if you use this stego image as it is for further diagnosis, there is a possibility that may lead to wrong diagnosis because of the changes that you did during data hiding process. That is the reason we are thinking about something called a reversible data hiding. So the concept is very simple. Let me quickly recap what exactly reversible framework. You are going to take an image. You are having a message also. You are embedding this message in the cover image. You will get an output image. You can call it is a stego image. And only that image you are going to transmit. And at the receiver side, receiver will extract the message and they will restore or recover the original image also. Okay, they are not going, even though the stego images look similar to the original image, the reversible data hiding scheme says that I need to get back the original image as it is. Okay, can you appreciate that? Yeah. Let us move forward. Yeah. Now, I just want to discuss one simple algorithm. I request all of you to listen carefully. We can easily understand the algorithm. If you understand this and if you want to take up some project or research work in future, you can do that. Whatever the algorithm I'm discussing here, it's a bit old, maybe 2008 or 2009, it's introduced, but still people are working on many extended version with the same concept. Okay, even 2020 or 21 also, we tried a extended version and we have some publications also in the same area. So even though if you don't have any background knowledge also, we can easily understand. Okay. Okay, let us assume that what is our objective? Our objective is we want to perform reversible data hiding. What do you mean by reversible data hiding? We have an image, we want to embed some information, and at the receiver side, we want to restore the image and we want to extract the hidden information also. Now, for understanding purpose, let us assume that we are going to consider an image. Can anybody tell me what kind of image it is? Because initially we discussed about the different types of images, right? Can anybody answer what kind of images I am assumed here, whether it is a binary image or it is a grayscale image or it is a color image? Yeah, yeah, I can see the answers. Very good, Ansmol and Jilna. Anybody else want to answer that? Okay, maybe others are seeing the answers also, right? Yeah, it's a grayscale image. Very good. So in a grayscale image, you know, the pixel value will vary from 0 to 255 in a normal situation. Okay. And what is the size of this image? Generally, we will represent the size of the image. So the size of this image is just 4 into 4. What do you mean by 4 into 4? You can see that this is a matrix of size 4 rows and 4 columns. So I'm saying that this is a grayscale image which contain, or which this is a grayscale image which is having a size 4 into 4 pixels. Okay. Okay, good. Now, the first step in histogram shifting based reversible data hiding is find the histogram. Oh my God, what is histogram? Anybody heard about histogram? It may not be in image processing. Can anybody, whether anybody heard about histogram or it is very new to you? What is a histogram? Please try to answer. What is a histogram? Specifically, what is a histogram of an image? Anyone can try to answer. No answers. Okay, fine. Whether anybody heard about, can I get a yes or no answer? Very good, Ansmol. I can see your answer. Graphical representation. Yes, Jelna, you are also correct. Yeah, Ansmol is saying frequency distribution. Yes, both are correct. Okay. So basically, histogram of an image is nothing but, see, you can see different pixel value here, right? What all are the possible pixel values in a grayscale image? We know like a pixel value 0 can be there, 1 can be there, 2 can be there, 3 can be there. Like that, it can go up to 255. Okay, in a grayscale image, we can see the pixel values from 20 to 255. Now, a histogram of an image is nothing but you are trying to store the count of each pixel value. Okay, for example, how many zeros are here in this image? Do we have any number of zeros here? Can I get a yes or no answer? Do we have any zeros in this image? Anybody? Do we have any pixels here in this image with a 0 value? Very good. Yeah, I'm getting answers. Good. Zeros are not there, right? Yeah. So what I will store the count of zeros is 0. Do we have any 1? No. 0 ones. Do we have any 2? No. But whenever you are coming into the pixel value 48 or 50 or 51 like that, you will be getting some count here. You can see that there are some 50s are there, 2, 3 50s are there, 4, 5 or 6 or 7 51 is there. So basically a histogram is a array in which you will be storing. Yeah, thank you, Manulal, for your answer also. Yes, we don't have any zeros here. So basically, we are trying to store the frequency of each pixel value. And histogram, you can assume that it is a one-dimensional array in which you will be storing the count. Okay, what will be the size of a histogram array? Like we are trying to store the frequency of each pixel value in an array. The first value indicate that how many zeros are there. The second value indicate that how many ones are there. The third value indicate that how many twos are there. And what is the last value in that array indicate? It is how many 255s are there. Okay. So now what will be the size of the histogram if you consider it as an array? Can anybody tell? Quick answer. What will be, I will repeat my question. What will be the size of the histogram array of a grayscale image? So it is basically we are trying to store the frequency of each pixel value. So what will be the size of the histogram array? It is different from the image size. Can anybody quickly answer? Manulal or Jelna or anybody can take. What will be the size of a Manu, you are very close, but anybody? Yes, 256 is the right answer. Basically, you know, like zeros is also there up to 255, right? 0, 1, 2, 3 up to 255. So 256 will be the size of the histogram array. Okay. And the first value indicate how many zeros are there. Okay. Second value indicate how many ones are there, like that. So I have taken a few portion of the histogram array and it will be like this. What is this basically? 48. How many 48? This you can assume this is the index of the array and this is the count. Okay. 49 only 1, 52, 51, 7, 52, 2, like that. This is the frequency. Okay. Even you can try to, as I think who mentioned, yeah, Jilna was mentioning that it is a graphical representation histogram. Exactly. Generally, we will try to represent this as a bar graph. If you represent it as a bar graph, you can see that 48, what is the frequency? 49, what is the frequency? 50, what is the frequency? 51, what is the frequency, like that. So we are trying to, we can try to represent it as a graph also, a bar graph kind of thing. Now, in histogram shifting based RDS scheme, the second step is you have to find out the peak pixel value. Peak pixel value in the sense you have to find out which pixel is repeating more number of times in your image. Can you help me to find out the peak pixel value? Which pixel is repeating more number of times in this image? Yes, I'm getting some answer. Jilna, very good. Yes, and small is also answering very good. Manulal, yes. Yes, 51 is repeating. What is the frequency of that? 7, right? Yeah, so now we know some basic, the first two steps we move forward, right? We have an image. We know this is a grayscale image is having some particular size. We try to find out the histogram of the image. Histogram is nothing but the each pixel value, how many times it is repeating. So we got a histogram. And at the next step, we need to find out which is the peak value. 51 is the peak value. 51 in the sense whichever the pixel is repeating more number of time. Okay. Yeah, if you see the IPL matches, you can see it's like a Chahals over more number of runs scored, something like that. Okay. Yes. So this is the peak pixel value. Now you know the two steps. We identify the histogram. We find the peak value. Very simple steps. Move forward. Now, see what is the frequency of the peak? That is basically 7, right? Let me use two variables to move forward in a better way. The frequency I'm trying to use, P freq, I am saying that it is 7. How many times 51 is repeating? And the peak pixel value, I am calling it is 51. That is with P. Okay, what is P? Which pixel is repeating more number of time? What is P freq? How many times it is repeating? Okay, let me ask you one quick question. Okay, you can answer yes or no question. is there is any possibility 2 pixels can have the same frequency? Is there is any possibility in an image 2 pixels can have the same frequency? Yes, you are right, Manu and Ans. You are right. We can have, Jilna, you are correct. We can have, for example, 50 and 51 can have the same frequency. There is a possibility all the pixels are uniformly distributed. Every pixels are almost same number. That can also happen. Then which one you will do? Which one pixel you will pick? You can pick anyone. Okay, you can pick anyone. You can take it as a peak pixel value. Okay. Yes. Now, yeah. Now what we are going to do, the next step is we are having an image here. This is our origin image. You can see the pixel values also here. You try to consider these pixel values one by one. Okay, like if you have some experience on writing some code on a matrix addition or something, what you will do? You will consider the first pixel value in the matrix, then you will go next, then second row you will come, like that you will process, right? Similarly, you are going to do the same kind of activity here. Basically, you are going to scan the pixels one by one from this pixel. Okay, and can you tell me, I just shaded some of the pixel values here with the green color. Okay, and some of the pixel values I haven't touched, it is with a white background color, right? So can you tell me what is the property of this green color or shaded pixel values? What is the property of these pixel values? Can anybody tell? Of course, you can see the slide also. I won't bother whether you are seeing the slide. Very good, Jilna, you are right. You can see that I tried to denoted the pixels which are greater than 51 with the green color. Okay. Yes. Now, what we are going to do, I'm going to do a simple operation. Whichever the pixel values are greater than the peak pixel value, which means 51 in this context, I'm going to increment the value by 1. So what will happen? Whether I want to, let us consider the first pixel value. It is 50. Should I do something on that? No, because it is less than or equal to 51. You do not want to do anything. What about the next pixel value? It is 51. Should I want to do anything here? No. You want to increment the pixel with the pixel value greater than P. What about this 52? Yes, it is greater than P. Then you should increment it by 1. If you increment the pixel value 52 by 1, what is the value you are going to get? You are going to get a 53. Okay. Next pixel is 51. Do I want to do any changes? No, I do not want to do any changes because it is less than or equal to P. 48, should I do anything? No, you do not want to do anything. What about the next pixel, 53? I will be changing the pixel value by incrementing by 1, 54. Okay. So can anybody tell me quickly 54, what is the new value for 54? Because it is greater than P. What will be the new value? Exactly, it will be 55. You are just adding simple mathematics, right? Just adding one to that pixel value. But only one thing, you are not going to add to the every pixel. Only the pixel value, if it is greater than P, you are going to add. Okay. You will appreciate why we are doing all those things and how we can restore the image. So I think up to here, up to this step, we don't have any concern. We considered the image, we created the histogram, you find out the peak pixel value, you considered each pixel one by one. If that pixel value is greater than the peak, you will increment by 1. If it is less than or equal to P, you will keep it unchanged. You are not going to modify anything. Okay. Now, if I draw the histogram of this modified image, you did some modification, right? If you see the histogram of this modified image, can you tell me this histogram image, can you see, and can you tell me some property that you are observing in the histogram? It's an open question. Anyone can try to answer that. Yeah, we have some time constraint also, but I just want to make sure you are following the discussion. What kind of property you can see here in the histogram? You can write anything, whether it need not be what I'm looking for. It will be great if what I'm looking for, if you can answer that itself. What is the property we can see in this histogram? Just see this histogram and tell me one property. Whether there will be any changes in 48, 49, 50 or 51. Whether any changes will be there for the pixel value 48, 49, 50 or 51, or it will be like the old histogram, how it was there, the same way. I think it will be in the same way, right? What kind of property you are seeing here? Yeah, anyone can answer that. Just give in some 30 seconds. I know you want to type it. Yeah, you can make mistake. No problem at all. I told this is an informal interaction. We can try to understand together. We can try to. No answers. Okay, fine. Okay, maybe my question not clear for you. See, you can see that what is the property of 52 in this histogram? Yes, I'm getting some answer. Pixel, yeah, Ansmal, you're right. Pixel values are shifted. That is one thing. Okay, and you can see that there is no pixel with 52. What might be the reason? Because 52 you incremented by 1, it will go 53. 51 you didn't change. Okay, and if 52 you incremented by 1, then what will happen? There will not be any 52 in this image. Or I should say that PK, if P is the peak pixel value, there will not be any pixel value with the P plus 1 after doing the histogram shifting. Can you agree with that? Or still some concern? Because 52 you shifted to 53. 53 will go into 54. 54 will go into 55. So all pixel values are moved here. Okay, fine. Now, what you are going to do, this is the shifted histogram shifted image. Now, whenever I want to embed anything, what I am going to do, I am going to consider this histogram shifted image. Okay. Now, the question, one of the basic question, how much amount of data we can embed in this image? Okay, how much amount of data we can embed in this image? Can you tell me, can anyone make a blind guess how many number of bits I can embed in this image? Just make a blind guess. How many number of bits I can embed into this image? Just give the number. Jilna or Ansmol or Manu or anyone can make an attempt because we are more active in the session. Yeah. How many number of bit you think I can embed in this image based on histogram shifting? Total 16 pixels are there. 51 is the peak pixel value. It is repeating 7 number of times. Okay. By considering all these things, can you do a blind guess? Let it go wrong. No worries. Any answer? Can anybody answer that? No, let it go wrong. No worries. Yes, I got some answer. Manu, 255 pixel value. No, not exactly. Anybody else want to answer? I appreciate your attempt. Yeah. Anybody else? How many bits I can embed? My question is very simple. I'm going to embed some number of bits in this image. Okay, fine. Okay, yeah, you don't want to try your luck. Fine. Let me tell you. Basically, we know like there are 7 times the peak pixel value is repeating, right? So I can embed 7 number of bits in this image. What do you mean by 7 number of bits? I can take a bit sequence which contains 7 bits. I can embed this message in this image. Okay, are you following? Yes. Now, what is the embedding process? I can tell you. You consider the pixels in the cover image one by one. Okay. And if the pixel value is equal to P, then you can embed. Okay. Whenever you are finding a pixel value with the value P, you can embed one bit there. One bit, only one bit. You know what is a bit, right? 0 or 1. Okay. Whenever you are finding a pixel value with the P, you can embed one bit there. How many P's are there in our image? 7 in this example. Or it is P is nothing but the frequency of the peak pixel value. Now what you will do, if the pixel value is not equal to P, then you will just leave as it is. You will not do anything. And you are going to consider that image that you got after histogram shifting. Okay. Now I need your help. I request all to listen carefully and help me to move forward. Okay, this is the histogram shifted image. Now, can anybody tell me what is the green colored pixel here? What is the property of green colored pixel here? Can I get quick answer? Very good, Jilna. It is a p value. Okay, I highlighted this p value here. So we can embed only the bits in the pixel with the p value. Okay, how I'm considering a secret message like this 1011 like that. So this one I want to embed here. Whenever I want to embed, what I will try to do, I'm considering the first data bit. I will consider the first pixel. I will check the first pixel whether it is not equal to P or not. If it is not equal to P, you will not do any changes. You will keep as it is. Next, you are going to the next pixel. The pixel value is 51. It is equal to P, right? Then what you will do? You can add that pixel value into that pixel. You will be getting 52. Okay. So like that, you will move forward. Next bit is 0. This pixel, what is it? 53. You cannot embed here. Whenever you are finding 51, there you can add the data bit. You can just add the data bit with that one. So 51 with the 51, what is the value? 51. So you will replace this pixel value with the 51. Okay. Are you getting my point? Then what will happen? You consider this one bit, you embedded here. Okay. This is the image you got after histogram shifting, and this is after embedding. So wherever 52, you have any idea where I'm getting 52 and wherever I'm getting 51? Where I will be getting 52. 52 is the pixel where you embedded the bit value 1. And whenever you are embedding the bit value 0 in the pixel with the value 51, there will not be any changes. Okay. Now, sir, I will take 2 minutes, 2-3 minutes, then we'll wind up. Sir.
Yes, please.
Yeah, yeah, thank you. Now, at the receiver side, what we are going to do basically, we will try to check the pixel value. Okay, if the pixel value is less than P, okay, we are assuming that the receiver knows what is the P value. And if the pixel value is less than P, you will keep it as it is. You will not do any changes. But whenever you are finding 52, what you will do? You will be extracting 1 and you will decrement by 1. Okay. And the receiver must know what is the P value. You can assume that the P value is a kind of key value kind of thing. Okay. It's a key kind of thing. The receiver already knows that. Whenever 53 is coming, you know, like it is greater than P plus 1, then you will, to restore this pixel value, you will just decrement by 1. You are not going to extract anything. Whenever you are finding 51, what is the meaning of that? You will extract 0 from that. If you find a P value, you will extract 0. If you find a P plus 1, you will extract 1 and you will decrement by 1. If you find any pixel value greater than P plus 1, then you will just decrement, no extraction. This is the overall process. Finally, what we are going to get, you can see that you will be getting that the embedded message as it is as extracted message. And this is the recovered image. This recovered image will be nothing but the original image that you have seen at the beginning. This one. Okay, both will be matching. Okay. Yeah. Now I have a couple of quick questions. Why we pick the peak pixel value? Can we pick any other pixel value so that I can proceed in the same way? Can anybody take that question? Manu, Jilna, or Ansmol, or anybody? I know some of you are faculty. Just excuse me, I'm just calling the name. Yeah, can any one of you can take that question? Can we pick any other pixel value? Yeah, from Manu, I'm getting an answer for maximum. Yes, exactly, Manu. You're clearly got the point. See, we are considering the peak pixel value. The reason is that we need to embed more information. RDS scheme is worried about embedding more information. Okay. Yes, exactly, Jelna. You also got the same point. Yes, exactly. If you take any other pixel value with the frequency is 2 or 3, then you can embed only 3 bits. But our ultimate objective as a as a group of people working in this domain, we can tell you our objective is we need to come up with a RDS scheme which can embed more information so that we can use it in some practical situations. Okay. Okay. Can you just tell me maybe? Okay, it's already exceeded the time. Maybe any questions I can take it. I just want to conclude. I'm just concluding. I hope we got some basic idea about what is a digital image. Okay, at least there are 3 types of image: grayscale image or binary image, and color images are there. And we have some idea what is image security. Okay, what is image security? It's a set of activity that we will use to ensure that images are not modified or illegally transferred. Okay, or we want to provide the confidentiality. All set of activities we can call it is comes under the umbrella image security. Okay, and you got some overall idea about image encryption and watermarking also. Okay, and you know what is RDS, reversible data hiding, and we discussed the algorithm also. Certainly I will share this slides. You can, it's self-explanatory. You can go through that and you can try to understand the things in a better way. Okay, as I told, this is bit old algorithm, but as a first step, if you are a person interested to work in this domain, you can slowly start with that so that you can think about some new algorithms. I'm assuming that you all got some idea about RDS and you may be getting some better algorithms so that you can work in this direction. Syllabus sir, maybe I'm done.
Thank you so much, sir, for your valuable contribution. Any questions?
Any questions from audience side?
Yeah, so I have one question. I will take it from chat. If we have more data than p-value, then what we will do? Yes, it's a very meaningful question. See, let us assume that you have a 1 liter water bottle. Okay, how much you can pour in that? You can pour only 1 liter. If you are pouring more than that, it's going to flow out, right? So that's why every scheme, every reversible data hiding scheme will have a threshold in such a way that you can embed, which will not compromise the image recoverability. We are concerned about the restoration of the image also, right? So your question is very valid and small. In this scheme, we are considered the very basic scheme. As per the scheme, we can only embed p number of bits in the image. But people worked more in this, okay? And they come up with a variation of the this basic version, such a way that they can embed more information. That doesn't mean that there is no limit. Every scheme will be having a limit. You can maximum that many number of bits only will be able to embed. Okay. Yes. Of course, whether this will help in the to do the research in the area of cybersecurity, I hope yes, because cybersecurity basically we are trying to consider or we want to provide the security for any kind of data, right? This RDS scheme you can extend into something called a reversible watermarking schemes. Okay, and what you can try to do, a simple framework I can tell you. you are sending an image from one place to another, and at the receiver side, you want to ensure that that image is not modified by any third person. Okay. To do that, you can think about reversible watermarking, in which you can try to embed a watermark, and the receiver, what the receiver will try to do, they will try to extract the watermark and they will restore the original image. If the extracted watermark, if they can compare with the original watermark they are having, they can ensure that the image is not modified. Okay, something like that. We can say that this is related to security only. Of course, you can try to extend your research in this domain also. I hope I answered, RK. If you want to clarify in a better way, even I don't mind if you want to talk also. So any other question? Okay, can I ask you one question to you? Do we have any concerns in this approach? Whether I can restore all the time, whether I will be able to restore the image, or do I have any concern? Like whether the system will work all the time, 100% recovery, or do we have any concern? Can anybody type that question? Okay, let us assume that we are having some 254 pixel value, pixels with the 254 in the image. We are also having some pixels with the 255 also in the image. Now, when you are doing the shifting, what shifting process says? If the pixel value is greater than P, we want to increment by 1, right? Then what will happen? 254 you will increment by 1, you will be getting 255, right? Okay, then what will happen? Like what will happen for 255? Can I increment 255 by 1 and can I keep it in 56? No, you know, like in a 8-bit pixels, we can keep maximum 255. Okay, so 255 you cannot increment by 1 because of overflow, I should say. Okay, yeah, overflow, I should say. So then 254s will come and will say that I am 255. 255 have to stay as 255. Now I will not be able to distinguish 255 and 254 when I want to restore the image. Okay, so this is a key concern. We are calling it is overflow. Okay, and you can think about some technique to handle this overflow such a way that you will be able to restore 254 and 255 also. Yeah, I'm bit quick. I'm talking bit quickly, but I hope you are following. And it's good to see RK answer that. Okay, he got the point. Anybody else, those who involved actively in the meeting, they can clarify anything. Any basic questions you can ask. It's a very interesting problem. This is, I should say, when I did my PhD, this is the first algorithm I studied completely. So I'm very confident to discuss this. And it's very interesting also. We will appreciate what exactly happening here. Okay, sir. I think no questions means we can leave. Yeah.
Yes, sir. Fine.
Yes, sir.
Santosh,
Yeah.
sir?
Yes, sir. Yes, sir. We can do. Okay, sir. Thank you so much, sir.
Yes, sir. And I thank all the coordinators for their group for the kind invitation. And yeah, thank you so much, sir. Yeah.
Thank you,
Thank you
sir.
so much.
Yeah.
Wonderful
Sure.
lecture, sir. Thank you.
Yeah, I appreciate all the participants who involved in the discussion also. Dr. Bhagiraj, yeah, thank you for your comment. Yeah, we can leave, right, sir?
Yes,
Yes, sir.
yes,
Yes,
you
sir.
can.
Yeah.
Thank you.
See you,
We can
sir.
start here.
Yeah,
Yes,
yeah.
Bye, sir.
Bye.
yeah. Dear participants, the morning session conclude now. The afternoon session will resume at 2:30. Okay, we'll meet at 2:30. Thank you.
Uh, yeah. Okay, please start, sir.
Yes, sir. Is it clear, sir?
Yeah, it's
Hello,
audible, sir, please.
Yes, okay. Thank you, sir. Ladies and gentlemen, it is my privilege to introduce Apurva Madam, who joins us today as a distinguished resource person for our workshop on contemporary image processing and cybersecurity applications. Apurva is a subject matter expert and content specialist at Unext Learning Private Limited under Manipal Group in the Department of Learning and Content academic team with nearly 14 years of experience in academia, industry, and research. She is a researcher in security analytics who, who has a strong investigative and attention to detail mindset. She is globally certified by EC Council as a computer hacking and forensic investigator, certified analyst from Brainspace, Oracle certified specialist, associate from Oracle, Google certified educator level 1, and certified digital trainer from TCS. She has also been granted 3 Indian patents and has authored a book on security in computing. She was awarded for leadership by the National Entrepreneurship Network, Wadhwani Foundation, and other NGOs. She has delivered innovative and infotainment based workshops, FDPs, and SDPs to corporate new heights, faculties, and students, and has also published research papers in reputed national and international journals and conferences. Please join me in welcoming Apurva Madam, who are privileged to have here today to share our expertise and insight with us. Thank you, madam. You can join.
Yeah, thank you, Santosh sir. Just to make sure I hope I'm audible, loud and clear.
Yes, madam. It is clear.
Oh, let me share this link. So thank you, sir, and thanks for the opportunity. So let me share the screen. Yes. Just to confirm, I hope the screen is visible.
Yes, madam. It is clear, visible now.
Okay. Thank you, sir. So, hello all. So, as we all know, so it is completely this 5 days workshop was with pertaining to the image applications as well as how you can use the image with respect to cybersecurity applications as well. So, the same way over here, we are going to, in today's session, we are completely going to give a heads up on the concept image forensics. So, which is as in forensics literally means that is a post-mortem work. So that we would be doing. And that post-mortem work, how is image playing a major role? So in what aspects image is playing a major role? So wherein that can act as a digital evidence and it is acceptable and it is admissible in the code of law. So this is the main aspect that we are mainly focusing on. Yeah, so the agenda. So how I have planned this, the 3 category agenda I have planned. So first, what is image forensics is all about and why is it required? And then how can we do this image forensics entire process? So the 3 category based. So I have divided this session on. So let's start first with what. So what is this image forensics is all about? So forensics. So the name itself says that it is a branch of digital forensics. Okay. So digital forensics as in the same. So with respect to the digital assets, as in like digital evidences, to be very precise. So the digital evidences that are available from the forensic perspective, as in, for example, digital assets, as in what could be in today's world. So what could be the possible digital evidences that can be considered for the forensic investigation. So one would be our mobile devices, right? The mobile devices and the data that has in mobile, if you see, of course, there will be social medias, that is Insta, wherein lot of pictures are taken and uploaded. So that serves. And if Insta, the cloud platform also comes into picture, and then the emails that we use, in the emails also, if we are sharing something, either it can be images, or either it can be videos, or it can be some hidden text information. So that is also considered as sorry, so one of the digital evidences, right? And apart from this, so there are lot of other digital evidences that are available. So now, for example, with whatever we are communicating, the Zoom application, so the recording also serves as a digital evidence, right? So, and this image forensics, it's not a totally different field, and it is not a totally new field, right from the age old. So we are using this as an age-old principle as well, right? All right, okay. And this focuses, as I told, forensics is a post-mortem work. What do we do? So the autopsy, right? The autopsy process, we try to find out something. The same process is applicable here as well. That is, it focuses on the recovery and analysis of digital images, okay? So why do we have to do it? So one thing, in order to first check whether the particular digital images, whatever we have extracted from the digital evidences, either it can be from mobile device, or it can be from a camera, or it can be a solid photographs that is available at the crime scene. So all this can serve as the evidence. That is one thing. And also to prove the authenticity. So digital images means, nowadays, if it is digital, authenticity is a big question. So how can we prove that? So all this also is a major aspect of image forensics. And the other one is whether the images are original. That is what nowadays, like the fake, wherein like morphing happens, and it is very easy to morph an image, as in like I can change the face of one person. So in an image, and with our very high-end tools, if we use very basic tools, it is very easy to find out, right? And the videos also, videos are nothing but a series of images, right? So in motion. So how the images are being used, whether it is original one or whether somebody has altered that image. So with respect to that also, in image forensics, it is playing a major role. So now, okay, fine. So all this is there. So where all this is applicable? First one, who are using this image forensics process? One is the law enforcement agencies. Yes, of course. In law enforcement agencies, what type of image is taken for investigation is surveillance footage, as in like the CCTV videos, as I mentioned. So it is, they just check the investigation frame by frame videos. So they split it into smaller chunks. Again, the images are added along with the motion. So surveillance footage is also considered. And then photographs from a crime scene. I'll show you a video where it like it is a mock crime scene investigation that is taken up. So wherein image forensics, where all right from the beginning, this image forensics plays a major role. So in law enforcement agencies, right from the surveillance footage, that plays as one of the evidence, and the other one is the photographs. Whatever photographs we take from the crime scene, later that photographs will be used for analysis purpose, right? And the second one is media people. So with image forensics is helping media as well. So why media? So nowadays that fake information on the fake images or fake videos, whatever is getting created, how do you prove that it is original? It is not. It is not something that is altered or which is out of the radar. So with respect to this media also, image forensics plays a major role. So they have a specific cybersecurity firm who work on this image forensics aspect as well. Before, for example, journalists. So once they take, so few people will say, no, this is mock. I am not at all the person who is there in an image. So before publishing something, the media people will also cross-check and they prove the authenticity of the photographs as well. So that whatever information is passed on to the public, it is a genuine. And moving on to the last one is the digital content creators. Okay, over there also what happens is nowadays, whatever is received, it is getting fabricated information. Okay, whatever images they are using. So that is the reason they tell that plagiarism concept is also giving a problem. Okay, so wherever images we are using, okay, it is always better to provide the authenticity or the from where the actual image is taken. Okay, so these are the three. Now, this image forensics, it is majorly helping in today's trend. So these three, and of course, there are other subcategories in each and every field. So this is about the gist of what is image forensics and where all it is serving as a helping hand. Moving on to the second category, that is why. So why is it required? Second, just minimize this. So why this image forensics is required? So let's explore that. So now if you see, so there is consider image is a photograph, right? Imagine that this is a photograph. I hope you all remember that. So there is the games that used to happen, find out the hidden items in an image, right? So let's do that a bit. And I hope like if you're able to put in your answers on the chat, so that will be really helpful. So consider that, okay, that there is a person, okay? There are two persons who are thinking that, okay, I have to hunt for these images. Consider that this is an entire image, the whole mess over here, whatever you are seeing, right? Consider that this is a image, okay? A image which has some evidences, okay? It is a crime scene image. Again, I repeat, consider whatever is shown over here, a mess of items as an image, okay? In that mess, we are supposed to find out these items. Okay, let me start with this particular person. Okay, he is thinking that, okay, I have to hunt for this. Imagine that you are a forensic investigator, and of course you collect a lot of photographs and then you put it on the murder bulletin board, right? So in that murder board, you check and then you start analyzing it, of course, through the naked eyes. So it is really difficult to analyze the image, right? But the first step, what they do is they analyze a given image through the naked eye. They just see if something they can find out, and then they go ahead for the higher end tools. Okay. Okay. Coming back to this, imagine that this is an image wherein it has a lot of items. Okay, and there is this information. This person is thinking that, okay, nobody is going to find this. Okay, there is some hidden hidden items in this mess. Are you able to find out? Yeah, one second. For better reachability, I was getting this message as unstable network. So for time being, I've stopped the video for a while. Okay. Okay, you can just put it on the chat window. Are you able to find this person, whatever the person is thinking? Are you at least able to find one of the item? Either it can be a globe in this entire mess, or a watch, or a dumbbell, or a sellotape runner, ink bottle, or a apple, eaten apple, and then a baseball. Are you able to find at least one item in this mess? I'll just open the chat. So the question was, consider that there is a mess, okay? This is a photograph from a crime scene, right? And there is a person over here, okay? And he is thinking of these items, to hunt for these items. So are you able to find out these items, at least one items from this entire mess is the question. So there is no hurry. Yes, okay. Thank you, ma'am. Thank you, Chilna, ma'am. Okay, so I got a response that yes, right. Obviously, we will be able to find out, right? So, for example, see, okay, so let me help first and then connect the concept, how it is related. So over here at the bottom of the mess, there is a apple. And okay, there is a dumbbell. I've just put the arrow mark. You can just check where all the items are there. And the sellotape runner, watch, and then the baseball, ink bottle, the globe. Yes. Over here, if you see these many items, of course, immediately I may not be able to find, right? So I may require a bit of time in order to find the hidden items and the mess. The same thing is with respect to image forensics also. It is not the case that, okay, once a photograph is taken, it is done and dusted. No, again and again. So they hunt for the same old. They just keep seeing the images again and again to find out whether they get some any information or the evidences, okay, that can you might that is why what happens is investigation. It is not a 1 day or a 2 day process. So depending on the complexity of the case, it takes a lot of time. So that it takes a lot of time, even though it looks simple, the whatever photographs we have taken, but it it is possible that the attackers, they think they are smart enough nowadays, hackers, they hide a lot of information in the image itself. So there was a lot of controversies that was going on with respect to this Leonardo da Vinci's Mona Lisa painting also. So many people, they say inside that eyeball of Mona Lisa, there is a letter which is hidden, right? So it is not a very new concept, okay, which we call it as steganography also, right? Hiding something inside an image, right? Hiding the secrecy inside the image. So the image is not a one-time cut. So we take the image, we analyze it, we go through it n number of times, right? So and each and every time there are a lot of chances wherein we get a lot of new information or that can the evidences that can be provided in the court. Of course, there are different laws. The evidence laws is also there. So what evidences can be considered and what evidences are not permissible in the court of law. All right. So I just wanted to show that. So it is not the case that the image inside the image, whatever image, a document or a video or a text, whatever is hidden inside the image, it is possible to crack it down. Okay. So that is the reason why I thought, okay, let me take a picto-based activity and then go ahead. All right. So let's move on. There are few real-time cases. Okay, so we are in Y category, right? Why image forensics is required, right? So these are few real-time cases. So wherein I've just removed the names. Okay, so because for integrity and ethical reasons, I've just removed this the actual names, the actual location where it has happened. But these are the cases wherein a lot of images are captured and the images are considered as a evidence. All right. Okay. The first one is posting obscene profiles. So over here, what had happened is, so I was involved as a part of forensic investigation. So this was a crime that had happened in South India only. So I don't want to mention the place. Okay. So the girl had complained, as in like there was a there it got leaked at social media. Okay. So there she already had a profile. Okay. So there was another profile that was created. Okay, with some all of her pictures being morphed and all obscene images were taken. She was also a bit skeptical, as in like, okay, what is it like? And she immediately complained to the cybercrime police that there is some issue with these images. These are not my images, but only my face is used, wherein image manipulation has happened or image was altered. So, and then the cybercrime also took a complaint and then they started the investigation process. So, gradually what had happened is, so this they started analyzing those images. So, and then they found out that, okay, so this is not your original image. They told that, okay, gradually they narrowed it down to a person. So, and then during the process of investigation, so even she was also tampered like anything. So, by asking lot of queries. So, they, of course, during the investigation process, once you get into the cybercrime, So you will have to answer all the queries that is being asked by the higher officials, the police officials, right? The same way. So she was also being asked a lot of queries which was not directly related to her. And then after a lot of days, so nearly it took 6 months to solve this case. So with the help of the other details, other digital assets as like a metadata information of that image, okay, whenever an image is taken, so there is something known as metadata. Metadata as in what are the other information, as in like where the image was taken, and then what is the source of that image, right? All that was, with the help of that, they were able to find out that it was not the original image. So that is supposed to be only her face was used, and then later it was narrowed down to her colleague itself. So wherein like just she rejected his marriage proposal, so he was not able to digest that. So he created the obscene pictures of hers and then released it on the social media. So that was one case. So with respect to image forensics, wherein it played a major role. Moving on to the second case is, so this is based on the blood spatter. Okay, so as in like once how the blood spatters across, so once you just pierce or once you poke onto a human body, how the blood comes out and how it gets splattered. So based on that angle and all, so they will find out the motive, the psychology of the murder also. So image forensics is not a single field which helps in narrowing it down to the attacker or the crime person. So it helps in getting the group of suspects also. From the group of suspects, so we actually find out the person who is involved in the crime, right? So coming to the case study 2, the blood spatter. So what happened is this happened in a abroad, wherein like so there was a murder that had happened, and I hope like everyone will be using the smart watches, right? So and nowadays smart watches comes with a lot of features, as in like the camera feature is there, and then it gets recorded also, voice gets recorded, right? So what had happened is in the smartwatch, so the images got captured, okay, as in like the but it was not clear enough, okay, it was not full HD print, but yes, so still it provided a baby step towards the investigation process. So how it was a murder with the help of a sharp object, okay, so how the sharp object was kept, and when the person tried to the murder, the person whoever was murdering, so at what angle the object was kept, that and all was recorded, and based on what is the psychology, and then what is the actual, and if you see there is a way wherein like medical officials keep the medical professionals, they keep the knife and they cut, they do the dissection process also, right? So what had happened is based on the way they're holding, so they narrowed it down for to a medical professional, right? So in that way also image is helpful. Okay, it is not the case that always the image should be a very high end or a very clear image, but still yes. So all from these small objects also, whatever images we get, so it helps in the investigation process. Okay, and it helps us like with what severity you pierce the sharp object gets pierced on the body. So based on that, the blood also oozes off, right? So at what angle it is and with what speed or what angle, so the murderer might have used the object, okay, and what type of object also is used, it is possible, okay, if the photograph is taken, right, of the autopsy and all, so that also will be helpful during the investigation process. Moving on to this third case study, where it's shoe prints. I hope this is very straightforward, right? So whatever photographs we take, either it can be like a normal photograph. So during the crime scene process, so once they get into the photograph gets into the crime scene, they take each and every bit of the photograph, okay? And the shoe print also, it serves as the shoe prints and the fingerprints. So it that is also those set of images also helps in cracking down the cases, okay? And the last case study is about the missing object. Oh, this is a very interesting case wherein what had happened was, so there was this also happened in India, and I hope like majority of the films now they have this concept also. So they keep looking, okay, as in like whenever we go to the crime scene, the photographer takes in and around the surroundings also the photographs, right? So what had happened was, so and I told you it is not a one-step process, right? So the photographs will be looked again and again, right? So and they would take other references also of the images. So before, in case if they find some photographs of the room or some whatever evidences were are there, so they try to take those evidences and all, they compare with the photographed image during after the crime has happened in the crime scene, okay? So in during the examination and comparison of the images, what was found is, so there were certain objects around the crime scene that was found missing, okay? So that also will serve as a major element, okay? So what had happened is, so there was a CCTV, as in like a hidden camera, which was kept in a private detective room, okay? So that private detective room, so later on, so during the interrogation with the mother of the person, the deceased person, so she was telling that no, he was working as a private detective, and then whatever work he was doing, he was recording. So whatever conversation that used to happen in his room with his clients, so it was getting recorded. And immediately the police officials got a new turn towards that investigation, and then they tried to take the CCTV footage and then they divided that into n number of frames and a series of static images. Okay, and during that that recorded CCTV footage and then the photo that was taken. So during the investigation process, right? So during the comparison, they found that a lot of objects as missing. Okay, uh, so that also will serve as one of the important cases. Okay, important step towards the investigation process. Okay, so these are few real-time cases wherein image as a evidence will help in the narrowing down the cases during the investigation process. Okay, so we are done with what category and then why category. Okay, what is image forensics? We are a bit clear enough, and then why image forensics is essential, where all it has helped. Okay, that we have seen. Now, moving on to how. Okay, fine, but how do we process this image forensics? We know what is image forensics is all about, and then where does it apply? Also, it is fine, but how are we? How are they going to do? Okay, so there are few tools that I would be discussing, and I was also pretty shocked when I was, because my area of research is security analytics, and I had interviewed a lot of CID officials and CBI people also. So, and when I work closely with the police department. So what had happened is, so while I was asking them for a certain set of resources, what they use. So they told that mainly we target the open source resources. So I was pretty shocked that, and then I asked, how do you rely on just open source? They told that we don't rely only on open source. There are few tools so that are really good enough, but later on we also check the authenticity of the evidences, whatever we check with the help of open source tools, with the tools that we use internally. Okay, so just few open source tools, whatever he shared with me, I thought, okay, so let me share it with you also. So, but the other internal tools, so for that, we require the license. Okay. Okay. How? Before knowing how we go with the image forensics details, I hope you would have gone through the basics of image and digital image or during all these 5 days, right? This is the 5th day. So let me give a quick brush up, okay? So from the forensic perspective, what all features of an image we have to consider during forensic examination, all right? Okay, so the first one, image is made up of something known as a pixel, right? So it's the smallest unit in a digital image. I'll not go very deep into it, just as a surface, okay? So pixels, a collection of pixels, okay? It makes a image, right? So these are like tiny square, and if it is a color image, so based on whatever color model we use, if it is RGB, red, green, blue, okay? So that based on that, the pixel color also varies, right? So the image is made up of a pixel. And then the quality of this pixel also matters, which we call it as resolution, right? So depending on the pixel density, okay, if you compress an image or if you do some modification on an image, right, this pixel value in that specific region, it varies, okay? So which we call it as one concept that we do is ETL, error level analysis, ELA. Okay, so that is one forensic process that is predominantly found. Okay, all right. So the resolution of the image is also decided and checked. And then pixel manipulation, that is what? Analyzing the inconsistencies of the pixel. So wherein it will be just to see, if I'll show you the image also. Okay, we have few hands-on also. I'll show it to you. If you see the image, it will be a normal image. But if you use the hands-on tools, you will come to, when you analyze that image, you will come to know that, okay, it is not the image that is supposed to be, but it is an image that has actually undergone a lot of modifications, right? So that is which we call it as, technically we call it as pixel manipulation. All right. And now moving on, that was just a very basic introduction about a digital image. What are the things that happens on a digital image, and what things we concentrate on the forensic, just as in pixel and the resolution, and then pixel manipulation happens. Okay, these are the things that we mainly look from the forensic person. Okay, there are other technical details also that we will learn in a short time. And color, okay, so there are different types of color models. But majorly, so for whatever I have worked on, majorly, so these were the color models that they predominantly use. Okay, one RGB, as we all know, it's a primary model, right? So wherein the combination of these three colors, red, green, and blue, so makes a color image. Okay, there is a grayscale image also that is there, right? So once, if you want to analyze it, so you convert from one scale to the other scale, right? So majorly with respect to color models, so there are two models that we use it from the forensic per se. One is the RGB and the second one is the CMYK. So CMYK, wherein cyan, magenta, yellow, and black. Okay. So this, right, it is used in printing process during that flex and all, right? So when we go with the printing printing process, they use these color combinations. Okay. So there was a case wherein, like in the flex, so nowadays what happens, like, so if they want to share the information in some way or the other, the attacker or the hacker are smart enough to use different methodologies, right? So as a forensic investigator, it is our duty to understand the basic ones as well. Okay, one is the RGB, the primary model, which is used in normal images, and the other one, which is predominantly focused on the printing part, as the CMYK model, cyan, magenta, yellow, and black. So based on these color combinations, varying intensities, they actually find out, okay, so whether a digital image or the printed version of the image, okay, so has undergone any modifications. Okay. Okay, so there are n number of image formats. Okay, let me tell you, there are n number of image formats, but we concentrate on these things. Okay, these image formats. So over here, the joint photographers experts group, right? The JPEG, okay, which is as in, like, the quality is okay, but it is not as good as the other images, right? So as in, like, vector images is also there, SVG, right? So but as the normal one, so the first one which we have to know as a for forensic investigator is a JPEG. Okay, from the forensic perspective, how does this type of image format helps us to track the degradation of the artifacts as in the digital assets, that is images. Okay, so this JPEG helps, this image happens to be present a lot of places. And the next one is portable networks graphics, PNG. Okay, so this and we have something known as lossy and lossless, right? Lossy as in, wherein, like, just in a layman language, if I have to put it, so lossy is the pixel doesn't lose its information, right? Doesn't lose its value. But in lossless, the pixel undergoes, wherein the values of pixels will undergo a lot of changes. Okay, so that I'm just mentioning it in a layman language. Okay, okay. So PNG as compared to JPEG, it is pretty good. Okay, it supports lossless compression, as in like whatever changes has happened, it is not predominantly seen on the images. Okay, so and it preserves the original evidence as well. Okay, all right. And the next one, this is one format that is predominantly we come across. Just give me a second. Just give me a second. Sorry for that. So moving on to the third image format, TIFF. So TIFF, which stands for Tag Image File Format. Okay. So this tag image file format are the files of this type of format are larger in size. Okay. So and they have additional details as well about the image. We will see what types of images are there and then what are the details that are there in the image. Okay. For now, let's understand what are the image formats from the forensic person. Okay. Okay. And it helps in the detailed examination of images. And raw. Raw is unprocessed image. Okay. As in like whatever we have, either you're capturing it from a camera or any capturing device. So without it undergoing any modifications or any enhancement to the images. So whatever we get it as an output, we call those set as raw files. Okay. So this raw files plays a very major role. So during investigation, what happens is, so imagine that I'm working on an image, right? So I take a hash value. I hope you're aware of the hashing concept, wherein there is a concept known as hashing, which takes care of integrity part. So when an image is taken or when an image will be used for the forensic examination, they do a process known as hashing. What it does is, for a given image, there are different algorithms for hashing. Okay. So I take a hash value. Hash value is for an image, I generate a fixed value. It's an alphanumerical value. Okay. So people who know about this, that is well and good. I'm just putting it in a layman language. Okay. So this hash value, right? Before starting the investigation, we take a hash value and keep it aside. All right. And then after the process and after analysis also, we take a hash value. Okay. So in case if we are sending the image to some analysis lab, okay, wherein the hash value plays a very major role, because when we submit the evidences in the court of law, we have to submit all this as well. So before the starting of the investigation, what was the hash value? After that, what is the hash value? All right. So hash value plays a major role as well. Okay. So that I thought, okay, I'll just mention that as well as we are dealing with the images. Right. Okay. So now moving on this raw, I hope you are able to understand this is unprocessed images. Okay. And next BMP, bitmap images, right? So there is over here what happened is raster images, we call it as, okay, it is similar to raster image as in like a pixelated image. Okay, it's a color based, but it's a pixelated image. All right, the bitmap images. Okay, if you want to understand about pixel level alterations that might have happened for an image, we usually go with the bitmap images. Okay, as in like it is not the case that okay, the one image to format is there. So if they want to analyze it, there are a lot of cases wherein from one image format we actually change it to other image format for analysis purpose. And if you want to know the detailed level of pixel alteration, usually we go with this type of image format, that is bit. Okay. And moving on to the GIF. GIF, I hope everyone knows it, graphics interchange format, wherein it is an animated image, right? So over here, just like what I have used, right? Why and all I have used the GIF images, okay? So what I meant is this one. So this is a GIF image, okay? So that also is used in the investigation process. Okay. So now, so how it is used is, again, because it is an animated image, and again we do frame by frame. Okay, static images we take, and then we find out whether some tampering has happened. Tampering as in like whether something is hidden inside the image. That is also being checked. And the other one is WebP format, which is developed by Google. Okay, so it also helps in handling the metadata and compression. Okay, if we are dealing with these types of image formats, it is, as a forensic investigator, we have to know what image format, with what image format, what all we can extract. Okay, so that is the reason I'm just highlighting these types of image formats. And the other one is the HDR, okay, high definition one, EXR. So which is from a HDR quality cameras. And this HDR says that it gives a full footage, okay, even in the light condition, okay, wherein the lighting is not perfect. So these type of images, it captures the information in a pretty good way, right? So we, because whenever we are submitting the chain of custody, right? So the sequence of events, or this whatever is happening in the investigation, we have to specify based on what image format we have worked on, and that image format, what is the hash value, and then we find out, that, okay, so this was the hash value, and then these are the information that is extracted from the images. All right. So yes, so this was the hint of the image format. Okay, so now the areas of attention. Image forensics is again a wide ocean. Okay, so among this, so the major ones which has grabbed the attention is, the first one is image manipulation. Image manipulation, as in if I crop an image, or if I edit the image, as in like if I reduce the color intensity or the opacity of the image, and there are a lot of cases wherein metadata also can be changed. Okay, and but there are other high-end tools, even if the metadata is changed. Okay, there are a lot of cases wherein you can recover the original data as well. Okay, so image manipulation involves all these, whether you're editing an image, cropping, analyzing the inconsistencies in the pixel values when it undergoes intensity is, imagine that I have an image, okay, and then I'm hiding something, okay. At that time, the compression level and the pixel intensity level, it varies, as in when you do the, what I told, the error level analysis, right? So it shows the highlighted, the image highlight, right, has to be uniform across the entire image. If the light and dark regions are varying drastically, it shows that the error is more in the image, and the pixel has undergone the modification. That I'll show it to you, what it is, and then how it varies from the original image. I'll show that also during the hands-on process. Okay. And the second one is source identification. This also has gained a lot of attention, and there is a lot of research work going on in this field, because source identification is getting tampered, and it has become a really challenging case in order to find out the source of an image. Okay. Sorry. And then integrity. So ensuring the image integrity. This is the place where I told you, whenever an image is taken, the hash value is found for that image. Okay. So in order to show that the image is not altered, okay, as in like before you, if you want to send an image, right? So you have to take a hash value and then send the image to the analysis lab. So once the analysis lab, the analyst receives the image, right? They again find the hash value, and then they check, okay, whether the two hash values are the same, or during the transit, whether the image has undergone any modifications. Okay. So image integrity also is a attention gaining field. All right. So these are three fields that I thought I'll spend a bit of time on. Okay. So let's see the few of the hands-on on this. So with respect to image manipulation, right? So how this image manipulation we can check is reverse image search. Even though we think that, okay, reverse image, it's just a normal one. No, gives a lot of information. It throws a lot of information for us. How the reverse image, this is with the help of Google only, Google image search. Okay. So how it helps. Okay. What happens over in reverse image search is, see, when you open Google image search, right? And there are a lot of cases wherein you get lot of images from the suspect machine. Okay, imagine that you are in a crime scene and then you have got lot of images from the suspect machine. So in first they take the hash value, that and all is fine. But after that, they try to use this Google image search in order to find out so whether the image, whatever is stored in the suspect machine, is the original one, okay, or something is hidden inside that. Okay, we will do that also over here. Okay, so they try to find out the size of the image and then the error level analysis. They compare both the source image and then the image that is placed on the suspect machine. I'm not telling that every time these method helps, but this is a process wherein like it is not the case that one tool serves our purpose. So we'll have to use n number of tools in order to proceed with the investigation. Okay. All right. And the next one is photo forensics. So all this photo forensics is a very famous tool. So I hope like most of you who are working on this image forensics would have heard about this. So wherein if you upload it, it tells about the error level analysis also. Okay, there are other features also which is possible that we will see. So image manipulation can be done with the help of reverse image search, that is the Google image search, photo forensics, open source tool, and it is a web-based tool. Okay, you need not download and install any softwares for that. And then metadata analysis. Okay, so this metadata analysis helps us to it reveals whether the image has undergone any manipulations or not, right? Okay, moving on to the next one, source identification. Again, it can be done with the help of EXIF tool, that is it has all. So once you click on the photo and if certain set of, especially that location services are on, right, it grabs all the details. How this Google photos or Google pictures works. So during this year, back ago, 1 year ago, so these are the images, how the grouping happens in Google photos or Google pictures. It is based on this EXIF details. Okay. So, and reverse image search. Again, Google image search also helps in order to find out the source of the image. And the next one is image integrity again. So what happens is, based on the hashing value, we can do it. And there are a lot of pretty other tools, okay, that helps us in generating the hash value. And again, Google image search, first they find out. So whatever images that they got on suspect machine, so is similar, whether they're getting similar photos on the Google. So based on that, they compare, okay, this is the image which we got from the suspect machine. And the other images, in case that we get similar image, there are a lot of chances wherein the similar images can be grabbed from the Google as well. Okay, there are a lot of possibilities to happen. Okay, so based on these three categories, so what are the tools that we use? Apart from this, they use different tools as well. Now, let's work on few of them. Okay, so let's do a bit of hands-on. In case if you have also joined, if you are using systems also, I will just share the sources. 1 second. Let me stop sharing the screen for a while. Just give me a second. I've just stopped sharing the screen. I'll just put this this links, okay? In case if you have joined through system and if you would want to work also, you're happy to do that. Just give me a second. I'm just pasting it. Yeah, okay. Yeah, I've shared it. I've just put it on the chat window as well. Let me open one by one and then show it. First is about Google, the reverse image search, that is the Google image search. Just give me a second. Okay, let me share the screen now. I hope now the screen will be visible. What I've done is I've just opened images.google.com. Okay, on my Chrome browser. I'm using the Chrome browser for this. And I've opened this image. Okay. Now, if I have to search, okay, something, wait, I've just downloaded some images. Okay. Let me use that. Okay, so this is the image. Okay, I hope the flower image is visible. Just to confirm.
Yes.
Oh, okay, thank you. So over here, so this image. So what did I do is, yeah. So thanks for the confirmation. Okay, so this I've just dragged and dropped. Okay, I've just downloaded this image. Okay, and then okay, over here you can drag and drop, or else I can upload a file also. I'll upload a file better. See, whatever file I've uploaded related to that I'm getting over here. I hope it is visible. See, search the image. Okay, over here I'm getting the first one. See, the related image. This is how what happens is, whatever suspect image we get, right, we actually first start, okay, first with a Google image. That is a very basic one, the baby step that we usually do. Okay, these are all scroll, and we have to see any related images are also there. But as for me, this image is going well with this. Okay, let me click on this and see exact matches, where all the exact matches are there. Okay, this also helps me to find out, okay, from this is where all the source of the image. Okay, so it will be helpful to get the source of the image. Okay, find image source is there over here as well. Let me click on that. So that is how you get it. Okay, see how many image sources are there. Okay, so then they try to narrow it down. Okay, based on the other details, whatever is being extracted during the investigation, they try to map the source along with the information, whatever is being grabbed. Okay, okay, this is one way of finding the source, right? And next one is, all right, hold on, or else I'll do one thing. So what did I do is, let me go back, images.google.com, and then okay, I've just dragged and dropped. It's just checking. Okay, see how many source of images. This I've downloaded from internet only. Okay, so this find image source I'm getting, see, from jpeg.org, the top ones, right? Whatever is listing at the top. So it is based on the ranking. Okay, usually during investigation, the top images, whatever is being grabbed, right? This links as the exact source of the exact images. So that will be given a lot of preference. Okay. Let me click on one of the image and see whether it is taking to that site. Yes, see, of course, I've downloaded from here, right? Okay, so this is one way of finding the source of the image. Okay, and let me use, let me share with this. Okay, the second link, whatever I've shared it, right? I'm going on with this imageforensic.org. Okay, right, imageforensic.org, the second link I'm using. Okay, so let me analyze my image. Okay, let me browse it. Let me browse my image. Okay, I've uploaded my image. Again, I repeat, what did I do is, so I went to the second link, www.imageforensic.org, the second link, whatever I've shared, okay, the second one, and then As soon as you open that link, this is the window that you see. Okay. And then I've browsed the image and then I've just put it over here. And then let me click on this analyze and see what types of analysis do we get. All these are open source tools, okay, that they use it. Okay. And there is one more tool that I'll tell you. Okay. See, I'll tell you the other also. This is a very good tool they were telling. See, this is how the static analysis is a static data. They're telling no metadata information, nothing is there. And then error level analysis, they're telling it is applicable. As in, it might have undergone this, some changes on the image. Let me click on this ELA. It is just blank. This is not helpful. There are other ways also wherein you can get the ELA. Okay, see, this is the one analyzed at what it is giving. Okay, in the morning, I just check. This is one way. Okay. There are, let me go and analyze the other image and then I'll show the other examples. Okay. That is one image. Okay. Now I will do one thing. Okay, drag and drop is not working. Analyze. I've just selected one more image wherein I've done some modification. See, it is showing the same. Okay, no signature match. Okay, the same thing it is showing. Not much information which I want is there in this. Okay, so there are few examples over here. Okay, I'll just show it to you. So in this site only, there are examples. See over here. So what all this chain of this also it gives us. See over here, signatures as in low, medium, high. Let me click on one of the images. You'll get to know. See like this. So if it has some, see over here, low, criticality low, signatures matched is 5. Okay. And then medium is 24, high is 5. Over here, what all is there? Okay. See, EXIF details. See, static data is there. And everything is in green color. Okay, it is applicable. Let us see what it is in EXIF. See, this is how it gives. If it has some source information, right? So all this information gets captured. Okay. Of course, it is helpful. But this one, what happens is, we usually take it and then we give it to the image experts or graphic designers, experts and all who are very good with the image, right? They tell us, okay, the GPS tag and from which make it was taken, Nikon Corporation, and then this artist who it is, and latitude, not the GPS location details from where it was taken. So there are a lot of other images which have done analysis also, but due to this privacy reasons, I'm just not showing over here. Okay, so I thought, okay, there are a few examples similar to the one which I have done. So I thought, okay, let me share that so that you get an idea what all information can be grabbed from an image. Okay, ELA, I'll show you. I don't know whether it is visible for you. Here there are cases wherein it is not totally black also. I'll just show you, not this one obviously. See, this is the signatures. So what type of signature is EXIF software? Yes, image software is detected. XMP, the creator tool is there. And then GPS info is available. Okay, which is, if you click on that, it tells also. So which is a high. So this risk is high in this. Okay. GPS information is available. City is available. Okay. It categorizes the severity based on the information. Whatever we have collected from the image, it categorizes into 3 categories: low, medium, high. All right. So this is also an excellent tool which we can use in order to find out the image manipulation. Right. Let's see, static, it just tells me Jan 20th, this is the time which it was analyzed. Okay. Thumbnail information, it is the XMP. So all this information will also serve as a evidence. Okay. All right. So this is one tool. Let me show another tool also. Hold on. This is a very interesting one. Here, I'm just using the third one. Okay, the fake image detector. Oh, okay. Yes, I hope it's visible. In case if it is not visible, just let me know. Yeah. Oh, all right. Now this, let me upload an image first. Okay, scan now. Okay, I've uploaded an image. Okay, and then I'm just clicking on scan. This is the problem over here. See, over here, if you see, looks like computer generated or modified image because I have modified that image. For that, a lot of ads that keeps on coming as well. Thank you, sir. Okay. See, if you see this image, it's so beautiful. We feel it, right? But I've modified this image. Okay. I'll tell you what I've done also later on. Once I show the other works, I'll show it in. Okay. So over here, it tells, looks like computer generated or modified image. Let me scan another one. It gives us like, okay, they use n number of tools. They don't. Sorry for that. I'll just upload one more image. Scan now. I'm just clicking on scan now. Processing. At times it is fast, at times it takes a bit of time. This also I've modified. Okay, see. So computer looks like computer generated, okay, or modified image. Okay, so it tells us. So if you give some image that is captured on camera, also it tells us. Okay, because I've tried that as well. Okay, it is working perfectly fine. So this is one tool so that we can use. The other one is my favorite, that is photo forensics. Yes, this is okay. So this is photo forensics, web-based. There are tutorials also how you can use this also if you're very much interested on if you want to explore a bit more on this, you're welcome to do that as well. Over here, there is an image URL. So wherein if I want to upload an image directly, I can do that as well. But now as I've downloaded the file, let me upload that image file. Don't think that why am I using the same old images? Okay, no. First I'll use the original image. Okay, I've selected the image and then see over here. I hope it is, see, error level. This is how the compression, it gets highlighted. Okay, so as in like equal ones, wherever the plain ones is there, it gives me the same one. And over here, so this is the error level analysis and metadata. Let me click on that metadata. See what all encoding process it has undergone. That information also we get. So the other details respective to the image, that also I'm getting over here. Okay, this is one very simple tool. Okay, it's not a very high-end tool as well. Okay, let me come back and let me upload one more file. The same file, I'm uploading the file. Now, if we compare it, right, over here, I've done a bit of modification to this image. Okay, so metadata. Okay, if you compare that, so earlier ones, right, I have changed that image and the encoding is not shown now. Okay, so with this also, this metadata information also it gives us. Okay, see, this was the earlier one, it had the encoding and all, that was the original image, but over here I have modified this image. I've hidden something inside this image. Okay, that is what. So over here from the metadata also, it is, we'll be knowing that okay, this image has to be analyzed further on. Okay, so this is one way of doing the analysis of forensics of an image. Okay, let me, okay, one second. Let me check picture order and let me use one more to decode. So there are a lot of online steganography that is available. Okay, so there is one famous one. I hope you would have heard of this one, which is OSINT framework. If you are very much interested in open source intelligence. So this open source intelligence is again yet another famous field. Okay, it's a research field and this it is very helpful for the forensic investigators also. Okay, what are the tools that are available Okay, OSINT stands for Open Source Intelligence. Okay, this is a framework. See how many categories are there. If you want to know the usernames, and over here, right? If I want to, and all are not open source tools also. Okay, as in few information you get from a open source tool. For example, if I want to know the email ID, okay, if I want to know the email ID, few letters of the email ID will be seen. So to get an idea, okay. So that is there, and public records, telephone numbers, people search engines. Now, as we are dealing with images, I'll just click on this. It gets expanded. See over here, webcams, videos, fonts, documents, and now I'll just select this image. See how many you can do. Search on Instagram, Flickr, metadata, forensics, OCR tools. Okay, let me click on forensics. See, photo forensics is there, that we know. This is also very good, but you have to install this. Okay, but there is a lot of dependency for this tool. Okay, wherein like MongoDB is required to be installed, and it is always better to install all the softwares, whatever we are doing on a virtual machine or a virtual box. Okay, so always it is better rather than doing it on a physical machine. Okay, that's the reason I thought, okay, let me use all the web-based tools too, so that even you will get an idea. Camera trace is there. Okay, let me click on this. If you click on that, no, it will take you. Okay, because I'm using this laptop also. Okay, this is photo forensics. See, now I don't want to remember all the links. I can't remember. This OSINT framework helps me to do that. Okay. See, in forensics, you got that. I'll show this. See, this is a GitHub one. You'll have to clone this GitHub link, and then you'll be able to use it. Okay. This is the software. Okay, but installation working, it takes a lot of time on this. But this is also a very good tool for analyzing the image. Okay, see, this is for forensic per se. Okay, metadata, I'll see what all it is. See, EXIF tool is there, EXIF viewer is there. Let me check on this. If you want to know n number of tools, right, takes a bit of time. See, related searches is there. We can search on this as well. But at times, no, few are not a reliable one also. Just checking over here. Okay, see. Okay, GeoSetter. This is yet another. All are open source tools, whatever is there, right? So they have put it in one place, and it helps us to get into this directly. Okay, image ops. See, image URL. So what all informations you can get. This is one way, and tools. Let me show over here. Encoding and decoding is there. See, CyberChef is a very good tool. It's a very good tool, and if you are into that CTF, capture the flag contest and all, right, CyberChef is like a wonder. It does wonder, and we use a lot over here. See, if you want to convert, and this image is like inside an image, if you found something, so which is in a different format, they actually take this, okay, and then they select the algorithms, and then they try to find out if some any useful information can be got from the code which will be hidden inside an image. That is also possible. Okay. So CyberChef is also a very good tool which I would highly recommend you to check to it. And then with respect to images, that's all. Okay. Here also there is metadata. Okay. Yeah. Over here with respect to metadata, FOCA is also a very good tool. So for this also it is you'll have to clone it and you'll have to install the tool. Okay, FOCA. Fingerprint organizations with collected archives. Okay, it goes through and it scans the documents also. See, these are the this one dependencies what you would require in order to install this FOCA tool. So this tool I've used, that is really good tool. EXIF also, it's a really good tool. So this is one way. So this is how this OSINT, and during capture the flag, this we use a lot of time. Okay, this is one thing is there, and I don't know how many of you have the practice of once you finish your flight journey. and just throw off. Nowadays, online is there. Online and the boarding passes and all, we don't use much of the hard copies, right? But still they give the boarding passes and all the hard copies, right? So there are lot of cases wherein the information was extracted from the boarding passes that was just thrown as such, okay, without shredding the boarding pass. If you just throw it as such, it is a hot cake for the attackers, okay. If they want to grab some information, right, it is very easy for them, okay. Let me show that few examples of it, okay. Again, I'm just giving you an idea. So wherein, like, because I didn't wanted to use the actual boarding pass, so I'll just use this link. One second. Wait, I've just collected the barcodes and all from the different boarding passes online. Okay, it's not the one, okay, which is there on the actual boarding pass which I've traveled. Over here, I'll have to see. Usually PDF, this portable data file, okay, PDF, which we say PDF 417. This is the type which usually it is used. So let me select this. QR code also nowadays it is coming. All this, I think if I'm not wrong, no, barcode and all, it comes with a Vistara Airways and all. So QR code is also there. So let me select that and keep, okay. Now I told you, right, I've selected few of the codes. Image means all this also is a part of an image, okay. So I thought, okay, let me show that and how that also helps in the forensic investigation per se. So let me select this image file which I've saved it and kept, okay. Okay, let me select this one. Read, okay. So what I did is I went to the last, that online barcode reader, and then I've selected this barcode. I've selected postal code. It's not a postal code. And if you want a driving license to be scanned, that is also possible. And then, but which has a QR code, I mean the barcode type. And the PDF 417, usually that particular format we use. And then the QR, okay. I have saved the file as in like just the code alone from the ticket. And then I have uploaded over here. Let me hit this read button and see what it comes. Yes. Okay. I see over here, see the signature value. It gives a lot of information. Okay. Over here, it is giving the name of the the name of the person as well, the flight numbers as well. Okay. From where all they have traveled. Okay. So all these details, it is easy to get. Still additional details also you can get it. Okay. So this is one. So always it is recommended to just spread it into pieces before it is discarded. Okay. The boarding passes, the hard copy of the boarding passes. Okay. This is one way. And let me show the other file also, which is a QR reader. Just selected that file. Click on read. It is giving me just this one airlines details. Okay. So what happens is, in case if you're investigating some machine and you're finding some QR codes, so this way you can analyze and we can come to know. And World Vector Airlines, okay, and we go and inquire over here. Okay, instead of not knowing anything, instead of not getting any leads in the investigation process, right? So this serves as a first step towards, or it shows a guiding path to start a new for the investigation process. Okay, it is not the case that okay, this is how we get the complete information. All right. Okay, this is one way of analyzing the barcodes. All right. And now let me show you one more. In case if an image has some additional information, as in like some steganography process, as in what is steganography? Hiding something inside an image, as an image inside an image is possible. File hiding inside the image, the file is also possible. As in the image is there inside the image, hiding of image is possible, hiding of file is possible, hiding of video is possible, audio is possible, and then the text is also possible. Okay, so that is what I'm showing it to you now. Okay, so there are a lot of works, okay, that is being given. So you can encode it also over here. See, encoding as in if you want to encode something, use an image and then write some message, encode the image. You'll get the encoded image here. and then you can download that encoded image, right? Now, I'm decoding the image, okay? Imagine that I've got an image, okay? Either they check in all possible ways. So if an image is there, they try all these ways in order to check whether they are finding some information, okay, based on the image. So now let me choose the image. Okay. Upload image. Okay. So this is the image that I showed it, okay? But I've encoded something. Let me decode that image. See, okay. As such, nothing is there over here. Okay, fine. All right, so I have done the changes with respect to, okay, I'll just show that with respect to error level analysis. Just give me a second. In photo forensics, yes, I forgot to include that. Just give me a second. So I'm just coming back to a photo forensics. And 1 second, wait. I had shown this, right? So ELA, okay, error level analysis. Okay, if you see over here, if you pay attention, so here and all this is highlighted, right? As in like the scale is normal, okay? It is not the case that it is too down. Okay, remember this one, okay? Whatever error level analysis is shown, let me come back, okay? Remember this, all right? Over here down, let me upload a new file. As in, I've just compressed that image, okay? Nothing I've done over here. See over here, fully dark it is, okay? Which shows that no. So there are changes in the pixel values. That is what I was telling you about error level analysis. I hope now we are able to differentiate it. First, whatever image I uploaded, right? The similar image of this. So over here, I was able to see this rose petals, the petals of that flower. But over here, I have just compressed that image as in like I've reduced or I've changed the pixel values. Okay, that is the reason if you see it is so much dark. So which gives us a hint that no, this is a modified image. Okay, so wherein it has to undergo still advanced analysis. All right. So this is the ELA which I thought I'll share it with you all. Okay. All right. So now okay, so there is one, let me reshare my screen. There is one small video which tells us, or before going to the video, just give me a second. I'm just resharing the screen. Okay, so this one, okay, I have done something to this image, okay. So like I thought, okay, let me share this image also so that even you can try it out, okay. So I'll just share the slides with the team so that you can try this out also, okay. So see, this image we have seen a lot of times, right? Right from the source of the image we are seeing. And then this is so looks so serene, right? It looks so beautiful and peaceful as well. But now I have done something onto this image. So I'll just show it to you. Okay. Let us come back to our row. Yes. So this decode one, okay, which I was telling you. So let me upload that image, okay. So I've encoded a message onto this, upload an image, okay. This was a image which I want the decoding process to happen. Okay, see, this is what was the message. You cracked it. Okay, this was a message that I hid inside this image. See, this is just a normal one, okay, but there are a lot of cases where So a lot of other codes also will be possible, okay, to be shared. So this is one way, okay. So wherein like inside the image, it is possible to hide something and then share it across, so that you don't get caught with the network components, okay. So this is one way. All right, and let me share one more one. Okay, I think I'll have to reshare it because it's a video file. So I have taken a mock. Okay, this is available on YouTube also, and it is a mock crime scene investigation. So what I did is when I was handling a course on computer forensics and investigation, wherein I had also I had also we myself and my students, we had done a film kind of, wherein I had generated the clues. It's a part of their activity, so it generates interest among students also. They'll have to crack down the codes, and then they'll have to find out who the suspect was. Okay, the suspect was also among the class members only. Okay, so in that way, there is a YouTube mock crime scene investigation also to show where all this image forensics plays a major role. So I was telling you right from the beginning, the image forensics plays a major role, right? So I'll just show that also. I'll just include the sound of this video too. Just give me a second. I'll just copy that link also. Yeah, I'll just put it on the chat window also. In case if it's difficult for you to view or hear, right? You can just listen to this also. It's a YouTube one which is available. So I've just shared that, and then I'm sharing over here also, and then I'll just fast forward it. The sound, okay. All right, I hope now. I hope it's audible, right? Just to confirm.
Yes,
Yes, madam. It is.
Okay, thank you, sir. All right. So what we had covered over here is, if you see from the entire video, I hope you would have got the pinch of it, as in like how the photographing, marking, and taking the images, photographing of the images of the evidences and all. So it gets a lot of importance, right? And that also gets captured in the evidence file. And there was one mistake over here. So because it was just a mock case investigation, wherein the cell phone was kept in a bag, okay, this evidence bag. So usually it is kept in a Faraday bag, which we usually say. I hope like most of you would be aware of it. So a Faraday bag, which is you get it on Amazon also, wherein like once you keep the electronic devices inside that, so the communication of the electronic device with the external network and the external environment gets cut, so that your evidences are intact. Okay, it is not getting tampered or anything, right? So all this will be taken and then analyzed at the lab. So photography or the image analysis happens right from the beginning. Okay, so right, it can be from the photographers or it can be from the evidences that is extracted from the crime scene. So all this will act as a evidence for our image analysis, right? I hope you would have got a hint on a real time scale how it happens.
Madam, is it over, madam?
Yes, sir. Yes.
Yeah.
Okay, thank you so much, madam, for your
Yes, sir.
valuable information. Any questions from audience? Any questions? Participants?
Thank you. Sorry if I've taken a bit of time, sir.
No
Okay,
problem,
so,
madam.
yeah.
I'll just stop sharing the screen.
Yeah, please. Thank you.
Yeah.
Thank you so much, Apurva ma'am. It's a wonderful session. It's comparatively compared to all other session, it's totally different. It's quite interesting also. Thank you so much, ma'am, for your valuable sessions.
Thank you, sir. And thank you for the entire team for giving the opportunity, and especially Dr. Silamberson, sir. So thanks for that.
Thank you.
I hope it was useful, and participants have gained at least a bit of information of how image forensics happens.
Yes, definitely. Definitely. Thank you, ma'am.
Yeah, thank you, sir. So I can leave the session, right?
Yes, yes. Thank you, ma'am.
Yes, madam. Sir, shall we continue? There is no need of rejoining. Almost time is 4:15 now. 4:12.
Participants are requested to be in online. So the validity function will start within 2 minutes. Good evening, ma'am.
Good afternoon, Dr. Silamarasan. Good afternoon, Dr. Santosh. Yeah. Director will soon join.
Good afternoon, madam.
Ma'am?
Good afternoon, Director sir. Director has joined. Yeah.
Yes. Good afternoon, sir.
Hello, sir.
I'm audible?
Yes, sir. Yes, sir.
Yeah, good.
Yes, sir. You're audible. Yeah. Yeah, Dr. Silamarasan, we can start, right?
Yes. Yes. Good evening to one and all. We are coming to the end of the 5 days FDP come workshop on contemporary image processing and cyber security application. We are in the validatory function. Now I call Dr. Santosh Kumar to give a welcome address.
Thank you, sir. Honorable Director, esteemed Registrar, distinguished speakers, respected head of the departments, faculty members, and my dear participants. A very good evening to all of you. It is great pleasure and sense of accomplishment that I welcome you to the valedictory function of our FDP come workshop on contemporary image processing and cyber security applications. Over the past 5 days, we have had privilege of exploring fascinating fields of image processing and cyber security, exploring new ideas, gaining valuable insights from our esteemed speakers. Today we gather to mark the conclusion of this enriching journey. It is moment of reflection and celebration of our collective learning and growth. I extend a warm welcome to our director, Dr. Raju V. Daraskar sir, whose vision and guidance have been instrumental in making this FDP come workshop a success. His unwavering support for academic endeavors enriches our learning experience and inspires us to strive for excellence. I also extend a warm welcome to our registrar, Dr. M. Radhakrishnan sir, in his absence. He is testament to the importance of institution places such as academic pursuits. Your encouragement motivates us to push beyond the boundaries and explore new origins. It is with great pleasure that I extend a warm welcome to our esteemed speakers for this workshop. Your dedication to sharing knowledge and fostering learning is truly commendable. Throughout this workshop, your presentations have not only enlightened us but have also inspired us. Your contribution have played a significant role in making this workshop a success. We are grateful for the time and effort you have invested in this workshop. Thank you for being a part of this journey with us. I extend a warm welcome to our head of the department CSC Cyber Security Dr. Panchami Madam and head of the department ECE Dr. Anas sir. Your mentorship have been invaluable. and we are grateful for your effort of making this workshop a memorable experience. I extend a warm welcome to the students from various institutes and our institute who have participated in this FTP workshop. Your enthusiasm and eagerness to learn are truly commendable. I hope this FDP workshop has been a rewarding experience for you all. As we come together to celebrate the culmination of this FDP workshop, let us also look ahead to the future with renewed zeal and determination. May the knowledge and insights gained here guide us in our future endeavors and inspire us to make a positive impact in the field of image processing and cybersecurity. Once again, I welcome each and every one of you to this valedictory function. May it, it be memorable and fulfilling experience for us all. Thank you.
Thank you, Santosh
Sir,
sir.
thank you, sir.
Yeah. Now I would like to invite Director sir to give the presidential address. Oh,
Okay. Good afternoon, everybody.
good afternoon.
Good afternoon, sir.
It's a great pleasure that Department of Cybersecurity under the leadership of Dr. Panchami and with the organization team, Sri Lambalsan and Santosh Kumar and remaining all faculty members, they have organized a wonderful program that is the image processing and cybersecurity applications. Friends, I'll happy to inform you that IIIT Kottayam is the only institute in India who could start BTech cybersecurity. Not a single IIT and NIT they are having BTech cybersecurity. Friends, along with BTech cybersecurity, we have started MTech cybersecurity, PhD cybersecurity. Around 20 members, 20 scholars are working under our commandos. I always say to my faculty, commandos. So they are working under them, and really they are doing very good job. Recently, there is one cybersecurity attack, and one of the PhD scholar, she is representing our IIIT under the leadership of Dr. Panchami. At every step, they are doing really wonderful job, and now I can proudly say that we are among the top 3 cybersecurity centers in India. Friends, it's not an easy game. Let's see what the complications of this cybersecurity. So when I joined I started my career. That time, no, I was not aware about even the concept of virus. It was not famous. In 1984, nothing was there. In 1990, first time we heard about virus, and that too in DOS environment and Windows environment. In 1994, we have developed virus scanner and cleaner. It was very challenging. No books are available, nothing was available, and we have developed the virus for, our BTech student have developed virus scanner and cleaner. It's a very challenging application because scanning is not very difficult. But cleaning the virus, it's a very, very difficult job. And that too, if you in those days, there were boot viruses, COM viruses, and file viruses. File viruses is really dangerous because while removing that virus part, we'll have to address the header file and all. So it's a very, and it depends upon the file, which type of file you're repairing. So successfully, we could clean in those days 4 viruses. And that was a grand success for our team it was in 1994. Friends, in those days, viruses could spread through files, through floppy disk and through LAN, local area networks. There is no other way to, replicate the virus, or virus can infect other files. But later on in 1996, the gravity situation has changed. Internet was there in India, and slowly through internet, viruses start spreading across the world. In 2005, But those viruses spreading is not that dangerous because it will attack directly to the organization, all computers through networks. After 2005, the situation has changed and this malware software started attacking particular person, particular organization. The capability has increased, the dimension has changed, and everything has changed. In those days, I like this field. It's my one of the field of research. We have registered. I have registered around out of 13 scholars. I have registered around 6 scholars in cybersecurity area. Say VANET forensic, database forensics, image forensic. I mean multimedia forensic, and network forensic and mobile forensics. Like that, so many areas we have covered. Friends, it was a very challenging experiment. In those days, books were not available. Proper books. If books are available, 2 books we cannot match. The content will be altogether different. For example, if you are doing operating system forensic, it was a very tough job because there are 2000 type of mobile hardwares and 300 types of mobile operating system. Now, how to do the forensic? Can you find a general solution? It was impossible. And in those days, without books, without literature, internet was even not in a good condition, not broadband. It is only a few kilobytes per minute. That kind of internet facility was available. And in those days, with all these problems, we have successfully managed. 5 PhDs are awarded, and they could do, contribute a really, they have done a really good job. Friends, after joining over here, we have 2 faculties, Dr. Panchami and Dr. Arun, and both are very strong. So we could dare to start cybersecurity. We thought about it, but it was too tough. Then Dr. Manjeet has joined, and then we have accepted the challenge and started first PhDs in cybersecurity. Then we have started MTech in cybersecurity and BTech in cybersecurity, a big challenge. And really, I'm proud of my team. All the faculties are, that's why I'm saying they are commandos, not the faculty. They have accepted the challenge. And now we are 14 in my cybersecurity department, plus Shao sir, and I can include Dr. Lindsay also. So the team of 16 members, they have submitted hundreds of projects. They organize all the faculty members, around 70 plus are there, organize 140 events, many on cybersecurity, and very challenging. Every topic is challenging. Every speaker they have selected very carefully, and they have maintained the quality. It's an institute of national importance, and we are trying to serve our nation, not only our student, but our society too. And that is why we are organizing such kind of programs. Friends, today, this is my second validatory function. In the morning, Dr. Panchami has invited me for 4th batch of police training. We are teaching them cybersecurity, along with that, mainly digital forensic. Friends, why I'm sometimes using cybersecurity and sometimes using digital forensic? The reason is when we have started BTech, MTech, and your PhDs and postdoc, etc. At that time, there were 3 choices: cybersecurity, which deals with the security of digital infrastructure. Second choice was digital forensic. No manpower was available for that, and that deals with the investigation, digital investigation of the incident. The third one is the hacking. So we prefer cybersecurity, but remember one thing: if you want to teach cybersecurity, you should have a knowledge of digital forensic as well as hacking. If you want to teach digital forensic, then you should have a knowledge of cybersecurity as well as hacking. All 3 are interdependent. But friend, the major challenge is in the police department, we know that police can play investigator role as well as security role, but here things are different. A cybersecurity person cannot play a role of digital forensic. He cannot do the investigation. Both the field are though the nomenclature is same, the subjects are different. For example, you can check database, multimedia security and multimedia forensic. These two are totally disjoint subject with the different tools. We'll have to apply different tools and we'll have to study in a different way. So friends, fortunately now we have mastery over the cyber security, digital forensic, as well as on the hacking. We have staff member on that, certified staff members. So friend, first of all, the first challenge while establishing this department is manpower. Trained manpower were not available in those days, and now even not today. So somehow we have managed the faculty. We got a really good faculty. The second challenge was managing the syllabus and curriculum and all. Successfully, we have referred, syllabus, curriculum across the globe. And now our syllabus is the robust one. It is an international standards syllabus. The third biggest challenge was your tools. In cybersecurity, the major problem is, for example, you are doing digital forensic. We have shown that this is evidence against the criminal, but we'll have to prove that evidence in a court of law. So whatever we are doing in our laboratory, same thing we should be able to replicate in front of court. But tools are dangerous. They sometimes give result A and sometimes give result B. So under such situation, it is difficult to create evidence which is acceptable for court of law. Friends, there are a number of challenges and we overcome all the challenges, and now we are directly helping society, right from police department, researchers, PhD scholars, staff members across the India through such events, and many more events we have planned in next 3 months, around 40 to 50 events. Keep watch on our side, and I'm sure that cybersecurity department will come up with many more events so that you can learn. And what I want is that I'm request for all the external candidates, join the hands, because today's world slogan is collaborate or die. So come forward, collaborate. We are ready to collaborate with any institute, any faculty member, so that we can grow together. Thank you very much for inviting me. Thank you. Jai
Thank you
Hind.
so much, sir. Thank you so much for your informative talk and your experience, sir.
Thank you, sir.
Now we can hear feedback from our participants. So voluntarily, you can give your valuable feedback to improve our things, our side, for the next upcoming events.
Good evening to you. So I am Dr. Ambika from IIIT Kottayam. Whether my voice is audible?
Yes, ma'am. Yes.
Yeah. First of all, I thank the organizing team and the institute for conducting this wonderful FDP. This FDP was lined up with more engaging and useful sessions on image processing and cybersecurity. Actually speaking, my area of research is machine learning. But as an outcome of this FDP, I gained more ideas about the cybersecurity and its applications. So it will be helpful to improvise my research career. So I really thank everyone for giving this opportunity. Thank you.
Thank you,
Keep conducting those workshops like this. Thank you.
Thank you.
Hello, sir. Am I audible?
Yes, ma'am. Yes.
Okay, good evening all. I am Dr. Jilna from Government Women's Polytechnic College, Kozhikode, Kerala. So first of all, I would like to take this opportunity to thank Dr. Silamarasan sir and Dr. Santosh sir for organizing this workshop. It's been really valuable. So I would say starting from day 1 to day 5, that is starting with advanced driving system session on that topic by Sumati ma'am to the last session on image forensics by Apurva madam. All the sessions were informative. First of all, when I looked into the schedule, actually I had a doubt whether I would be able to follow these topics, because most of the topics that were listed out in the schedule were new to me, except for one or two on security. But the resource persons, I would say, the time and effort that they put into in conducting the sessions, actually they started from the very basics, and they explained the concepts with such clarity that it was really easy to follow, to understand those concepts, and I'm really thankful to them all. And also they gave insights to various research domains. Though my area of research is secure communication, I could understand more about many topics like video summarization by Priyadarshini ma'am. And actually nowadays, earlier we used to work on a very single platform, either MATLAB or Python like that. But now it is, the thing is like if we work on both. The session on interoperability of both the MATLAB and Python by Anand sir, that was also really useful. And what I really found interesting was the way in which Kishore sir introduced that hardware designing, starting from a very simple algorithm of summation to that of algorithms or image processing. Actually, that was really interesting, I would say. Then the sessions on haze image restoration, a session by Jay Ganesh sir, I would specify, because the way he started the session, how the camera works to the way in which all those things are done. So all the sessions, what I would say is the expertise and the experience of the resource persons, they reflected in all the sessions. And once again, I would like to thank Team IIIT Kottayam for organizing this wonderful workshop. So looking forward for more such workshops from your side. Thank you all.
Thank you, ma'am, for your valuable feedback. Any other participant? Any other participant, if you want to share your experience, you can share.
Good evening, all of you.
Good evening.
Thank you for the opportunity. Thank you for the coordinators. Actually, I didn't start this FDP from the beginning. I came to know after 2 days, though I requested Silambar sir, and he allowed me and gave me opportunity to attend the FDP. Though I'm working a little bit, but some sessions I attended, some session I was logged in, but I couldn't hear. But whichever I have attended the sessions, it was very informative, and thank you. Director sir was telling it was one of the top university in the cybersecurity. Since I'm a PhD scholar, and is there any opportunities so we can work, and I can get some opportunities so we can work. Though I'm working right now in this Karnataka, one of the under the VTU. So if anything is there, I'll be very thankful.
Sure.
Yes.
Yeah, you can contact Dr. Panchami.
Yes, sir.
Her email ID is given at the website, and see that what are the possibilities, how we can help you.
Yes, sir. Thank you, sir. Thank you so much. And once again, thank you all for the valuable insights and all. Thank you, sir. Thank you so much.
Thank you, ma'am. Any participant you want to share your experience? Santosh sir?
Yes, sir.
Please. Okay. Thank you so much,
Yes, sir.
participants, for your valuable feedback. Now it's the time to give a vote of thanks. So once again, good evening to all. We are coming to end of this validity function of this 5 days FTP workshop on contemporary image processing and cybersecurity applications. I wanted to take a moment to express my heartiest gratitude to all who have made this event successful. Firstly, I would like to express my sincere gratitude to our Honorable Director, Sir, Dr. Rajubi Daraska, Sir. His vision and dedication have been instruments for making this event successful. And also, I would like to express my sincere gratitude to our beloved Registrar, Sir, Dr. Radhakrishnan, Sir, in his absence here, for his invaluable contribution and support in ensuring this FTP workshop a success. I want to thank our HODs, Dr. Panchami ma'am, Department of CSE Cyber Security, and Dr. Anand sir, Department of ECE. They are the backbone of this event. They are taking care of each and every step of this particular event. Then I want to thank our FTP workshop coordinator, Dr. Santosh Kumar sir. He is supporting in all the directions, right? I would like to express my deep gratitude to all the resource persons who have gracefully accepted our invitation. So they are be the part of this event. I believe that their sessions will bring to be extremely beneficial as per the feedback I came to know. Thank you. I want to thank our technical support team who have made all arrangement for this kind of online mode event. I want to thank our cybersecurity club, Elix club members, Cyber Labs, and Aspire research group members, PhD scholars for their continuous support. Last but not least, I want to thank all participants who graced this occasion with their presence. Your support means a lot to us. As per the request from Rajeshwari ma'am, we are ready to work together in future also. Hope you will continue this relationship strong. So we'll have mutually sharing the resource, right? Right. Then I would like to thank all the faculty members who have joined here. So once again, I thank all your supports to make this event a successful. Thank you. Thank you, one and all. Thank you, sir.
Thank you, sir.
Thank you, ma'am. Ma'am.
Sir, shall we start, sir?
Yeah, you can start. Ma'am, Panchami ma'am, that's all.
I think.
Yeah. Thank you, participants, for your wonderful support. We are expecting same kind of support in the future events also. Thank you.